Good morning, good afternoon, good evening, everybody. My name is Kartik, one of the co-founders of ETHGlobal, and I'm super excited to welcome all of you to ETHOnline Security Summit. Thank you so much for joining us again for the second week of this hackathon and the final week before submissions are due. This whole month is about building amazing things at scale. We have a 2,000 plus person hackathon going on with people from 100 different countries participating here. And we're also doing lots of summits to cover interesting topics that will make you a better developer and contributor to the Web3 space. And today is our summit of the week. So today is all about security. We're going to cover a lot of things on everything that's happening in the world of smart contracts and Web3 security. And the next 3 hours are going to be jam-packed with a lot of information and really, really cool things that I don't think we've done before in the past either. So let's get started. I want to give you an overview of what the next 3 hours look like, and then we'll go right into our very first talk of the day. We're going to start with talking about why security matters altogether in this space. When we're dealing with money, when we're dealing with really, really intricate and complex side effects for what we can do with a lot of smart contracts, understanding why this matters philosophically and objectively is very important. We're going to have Jack come on and share his thoughts on why you should think about this thing as first principles and also what Sherlock does. Also, a big part of what we want to happen today is not just cover what smart contract security looks like. We want to cover all the other ways you should be thinking about security and how security comes into consideration as we do a lot of the other components of building things in this space and scaling Ethereum. So our second talk for today will be, how do you think about securing and validating bridges? So not just contracts, but altogether what the whole system looks like when you have to interact with different chains. Then we're going to have Samrit talk about how DevSecOps can play a big role into building your projects and how you can think about security as a whole and not just like in contracts. The coolest thing we're going to have as our fourth talk is we're going to do a live contract audit with Patrick Collins. He's going to go into auditing something live on screen and talking through all the things that you can look for as a smart contract auditor or even as a developer trying to get into this space, and just spend an hour effectively talking about it, breaking down an existing code to see what vulnerabilities, best practices, and things that are going really well in those contracts and code bases. And then we're going to have Micah talk about striking the balance between innovation and safety in crypto, which means we want to cover all the things around how do you actually think about taking risk and building something that hasn't been done before to things that are super interesting primitives. And then we're going to close off with talks around formal verification in DeFi. So finding bugs from existing best practices is a great thing, but understanding how formal verification can help make that a guarantee is a really important distinction and just a good know-how. So we're going to bring on Sartora to share how formal verification works. And our last talk will be around securing zero-knowledge implementation. So much is happening in the world of ZKs, and thinking about how you can evaluate circuits, how you can evaluate how these proofs are being done, or how to think about vulnerabilities in zero-knowledge proof circuits is going to be not so easy, and we're going to make that easy for you by bringing on Peter and Lev to talk about how to think about security and best practices when writing circuits. So that's the whole agenda for today. Enough talking from me. These 8 speakers are going to come on and share a lot of their insights. So let's get right into it. Our first talk is Jack from Sherlock. I'm super excited to be talking about this first talk and bringing on Jack because 3 years ago, Jack got his start at ETHOnline, and now Sherlock is an amazing protocol, making security easy for all other projects out there. So it's with extreme pleasure. I want to invite Jack here on screen and have him really share all his thoughts on why security matters. Welcome, Jack.
Hey, Kartik. Awesome. Yeah, thanks for the intro. Super excited to be here. Like Kartik said, I think my first crypto hackathon was ETHOnline 3 years ago in 2020. So really excited to be here. And, you know, I felt really late getting into the crypto space when I was doing ETHOnline in 2020. And I'm sure you guys, you know, feel like you're late getting into the space and maybe you've missed so much and there's been 2 or 3 bull markets and whatnot. But it's 2020 ended up being super early, and 2023 is going to end up being super early. And there's, speaking from somebody who's been deep in the space for the last 3 years, once you get to the frontier of crypto, there's a million things to fix. There's a million problems. There's a million cool things that there just aren't enough smart people solving. So really excited that you guys are all here. And yeah, looking forward to getting into this security focused summit. And, if you're doing a hackathon, you might wonder, okay, why do I need to care about security? I'm just going to build something quickly and, put it on a test net. Maybe you'll even end up putting what you build onto mainnet. I think that would be awesome. But I also am here to warn you that if you do put it on mainnet, it will probably get hacked. And I can say that with a little bit of confidence after going through 100 audits with Sherlock and working with some of the top protocols and teams in the space. Writing Solidity is extremely difficult, and there are all kinds of gotchas, and there are all kinds of things that you think it's safe and it's broken for 3 different reasons. And if it's broken a little bit, you can steal everything out of the contract. So we're going to get into some of that stuff and hopefully convince you that, it might be worthwhile to spend a little bit of time focusing on security if you're going to take your hackathon project seriously after the hackathon, which I hope everyone does. So great, getting into it. Why crypto security matters. Let me see if I can. Okay, great. If you're new to crypto, you've probably still heard about a lot of the hacks, smart contract hacks, wallet hacks, private key hacks over the last few years. I mean, starting with the DAO hack, it's been many, many years of crypto hacks and very large hacks. I mean, I think everything on the screen right now is a 9-figure or 8-figure exploit. We're talking about very big numbers when things go wrong in crypto, and they go wrong often. And even the best teams using the best security practices, working with the best firms, still end up having issues, and there are still mistakes. And so, one of the most important things to know when you're starting out is like, well, why is this even happening? Why are there so many hacks in crypto, but like Bank of America or Barclays or, banks that I'm used to, they don't get hacked, all right? At least you don't hear about it. So the first thing to understand is kind of like, why is crypto so bad? Like, is everyone just reckless in this space, or what's going on here? And so, the question is like, well, does Bank of America get hacked? And we're going to get into that a little bit, but the short answer is yes, Bank of America gets hacked, but it doesn't matter if they get hacked, because they can just, if somebody hacks into Bank of America's mainframe code, whatever it's written in COBOL, and they change their own account balance from $0 to $10 million, Bank of America doesn't care. They can just go in and fix it. And that's because they have admin control. They control their database. And so the difference, which we'll get into as to why crypto hacks are much more deadly, is because no one controls the database. The code controls the database. So you might be thinking, well, then Bank of America is a lot better, because they can make sure that if you hard code $10 million in your account, they can go in and fix it. And if you send money to the wrong person, a lot of times they can fix that too. And they can fix all these things that make the traditional financial system like really awesome and make it has a lot of advantages compared to crypto. But there's a few disadvantages too. And there's one massive disadvantage, which is, okay, money always comes out of the ATM, but sometimes it actually doesn't. And if you live in the US like myself, or if you live in Europe or, some other countries, most people don't have any problem with the banking system, and the bank works and money comes out of the ATM and things are generally good. Like, why do I need to stop using my Chase account? Why do I need to put all my money in crypto? Well, crypto is really good for sort of the edge cases and sort of the things that you don't think will ever happen, and then all of a sudden they do happen. And I don't mean to call out Venezuela or Canada here. I'm sure there's plenty of people from those places, and they've experienced a little bit more firsthand compared to someone in the US why crypto is actually good and why it can be necessary. And again, the answer is Bank of America has admin control. And who has admin control over Bank of America? Well, the politicians have admin control over Bank of America. And so, in Venezuela, the politicians can control the supply of money. They can print more dollars out of nowhere, and they've been doing that super aggressively. Obviously, the US has been doing that a little bit too, but it hasn't quite caught up yet. And you might have heard about the Canadian trucking crisis, we'll call it, a couple of years ago, where Canadian truckers were parking their trucks in the middle of Canadian cities as a protest, and instead of giving them tickets and arresting them, the Canadian government shut off their bank account and said, your money is no longer your money. And so that's kind of one of the problems with having admin control, someone else having admin control over your bank account, is they can shut it off. And we haven't seen a lot of, awful examples of this, which is why most people don't see the real use case for crypto. But in the extreme examples, and if you're heading into certain scenarios, with a country or politically or whatever, all of a sudden crypto becomes the most useful thing in the entire world when it's a matter of, I have access to my life savings or I don't. So to recap, traditional finance, TradFi, you're trusting bankers, you're trusting politicians, you're giving people admin access to your money, essentially. In DeFi, you're trusting code. Only the code has access to your money and you. And so depending on how you look at it, that sounds really great. Or that could sound terrible. The code has to work very well. And if you're trusting the code, well, you're trusting it with your life savings effectively if you're putting your money in DeFi. So it's really a double-edged sword, but in the scenario where you want to have full admin control over your money and you want no one else to, nothing compares to DeFi and nothing compares to trusting code. On the other hand, trusting code is extremely dangerous. Here's a quick pop quiz. I don't think I can see the chat, but I'll leave this up for a minute. This is just an example of a really well-known and well-intentioned function, I guess, that works really well, except in one slight edge case. And some of you may be familiar with this, some of you won't. I'll give you a minute to kind of see if you can spot the bug in this small example. To give you some background on this piece of code, it's a POC written by a top security expert. His name's Gerard Persson, and it's for an audit that was conducted about a year and a half ago at this point. And I believe the third BZX hack was also related to this exact kind of mistake. And there was another $30 million hack that was related to this exact mistake that happened here, or a very similar one. So what you're looking at, $38 million or so has been lost because of essentially the problem in this code. And so now that you've had a little bit of time to look at it, I'll explain what's going on here. So all we're trying to do is transfer balances from one account to another. And this code works really great, except you might see this line, balances memory, balances from equals balances from. That is stored in memory. And the only way this code can be broken, essentially, which was not thought of, which is an edge case sort of, is if you set the from address and the to address to be the same exact address, you can steal all of the money out of this protocol. The reason for that is because if you look at balances memory, balances from, and then balances memory, balances to, you'll see that essentially what we're doing is we're setting the from address and the to address. We're essentially overwriting the from address with the to address because it's the same address. So if you put in the same address for from and to, you overwrite in memory the from address and you only have the to address. So essentially you are able to subtract the balance from your account, but then you overwrite that account and you add balance to it. and you essentially create money out of nothing. Like you create a balance out of nothing. And this is the only way that you can take advantage of this is by putting the same address in the from and to parameters. And if you do that, you will be able to steal all of the money out of the protocol that has this code. So that's just a small example of everything is well-intentioned, everything works really well, tiny edge case, every bit of TVL in your protocol is gone. All the money's gone. So it's tricky. And to get back to the main point here, bad TradFi security usually means your information gets lost. You know, we've all had our credit card information stolen. We've probably even had our social security or whatever stolen, 10 times at this point. And every time you see, an Equifax hack or a Target, hack or whatever, your information gets stolen again, and it's on another list. And this is bad, and it can end up in, credit card fraud and things like that. But for the most part, you don't lose your life savings when that happens. And a lot of times you don't even care that much if a database gets hacked and some of your information gets out there, because it's probably already out there to some extent. So bad TradFi security means you lose your information. They own your information. Bad Web3 security means they own your life savings. They're able to access the database and hack everything out of it. So if it was Bank of America's database, they could take literally all of the money out of Bank of America and say, this is mine now, using a bug like the one we just looked at. So, and that's why the bug bounties in Web3 are like 100 times higher in a lot of cases than the bug bounties in Web2, 10 to 100 times higher, because in Web3, the severity of the bug means that you can lose everything, or the protocol where you're putting your money, the app where you're putting your money, can lose everything. Whereas in traditional finance, the stakes are usually lower, and there's a lot of just guardrails and different things put in place to make sure that, even if your credit card information gets stolen, there's different services, Visa and whatnot, that will make sure that you're not losing your life savings. Your bank has different ways of doing that. And that's because in a lot of cases, they can basically just put in whatever they want to their database. And if you change their database, they don't care. They'll just change it back. So Web3 security is like way more crucial than it is, traditional cybersecurity. So that's really important to keep in mind, because it means that everything in Web3, everything in crypto has to be focused around security. So I guess, from Sherlock's viewpoint, we kind of see three main blockers to mass adoption. This is a little bit controversial, but it's essentially scalability, which is making sure that transactions can go through quickly. They can cost, a small amount of money. UX, you can have an app on your phone. You don't have to memorize your seed phrase. You don't have to do all of these different things. And then security is kind of the last one. Like if you are losing your life savings to a hack, you're not going to want to use that financial system anymore. And if that's how DeFi is going to be going, then DeFi is not going to be successful. So security is, at least from Sherlock's view, one of the main pillars to getting crypto to mass adoption. And for a little bit of background on Sherlock, Sherlock started out as a smart contract coverage provider. So basically, if a protocol gets hacked, Sherlock would help pay it back. If a protocol has a bug bounty submitted to it, basically a white hat, which is a good guy, saying, hey, I found a bug. I'm not going to hack this because I don't want, to be a bad guy, but I do want you to pay me something because I found this bug that could have caused a lot of damage. And so Sherlock helps protocols pay for those situations. And the reason Sherlock does this is because you can never prove that a smart contract is 100% safe. So security is super important. We already established that. And now we're bringing in the next piece, which is, oh, by the way, you can never prove that a smart contract you write is 100% safe. And so that's why Sherlock has this coverage protocol that we've built on mainnet. We've done all these things to try to help other protocols in the case where they have exploits, they have bug bounties, they have to pay out large amounts of money. And again, that's to help us get to mass adoption, because mainstream users are going to require not losing their life savings. If they lose their life savings, they're going to stop using crypto. And so that gets us to auditing. If you want to do smart contract coverage well, you want to limit exploits, you want to limit bug bounty payouts, you want to limit bugs, essentially. And the number one way to limit bugs in crypto right now is through auditing. And auditing just means people look for bugs in your smart contracts. And to give an example that's close to home, when Sherlock first started out, we weren't doing any auditing. We did not have our own audit process. We built that later. And so we relied on existing audit firms. And we built a protocol. We actually built 2 protocols. We got them audited by, I think, 5 different audit firms. And we had, frankly, really difficult experiences. The audit firms tried to find stuff, and it turned out they didn't find everything. And Sherlock nearly got hacked. I say nearly because a good guy, a white hat, found the bug instead of a bad guy. If a bad guy had found a bug, the bug that was missed, then Sherlock would have been hacked on mainnet. But instead, it was submitted to us through our bug bounty program. We paid the guy a ton of money for finding that bug. And, by the way, this was about 2 weeks after we had just paid a lot of money to an audit firm to try to find that bug, and they missed it. So auditing and security, it's really, really hard. You can have one of the best people in the space spend weeks looking at your smart contracts trying to find bugs, and they still might not find all the bugs. And in this case, it wasn't the auditors we hired who found the bug. It was some guy we had never heard of, never interfaced with, and he just happened to be looking through our contracts and found this bug. So that shows a little bit of the difficulty. Because of that, Sherlock got into auditing. We built our own audit process, and we combine an audit contest, which is essentially anyone in the world can participate and try to find bugs, and we'll pay them based on the bugs they find. And reserving top auditors, more like a traditional audit where you say, hey, I know this guy is good. I'm going to pay him a lot of money to spend all of his time looking for bugs in my smart contracts. And so Sherlock combines those 2 things, and we've been doing it for a little over a year now. We've audited Optimism and a bunch of other cool protocols. But in this case, focusing on Optimism, this is a little bit how this was the first audit we did with Optimism earlier this year. There were 2 reserved auditors, Zach Obront and Trust, really great guys, really top auditors. They were paid $10,000 a week just to show up and look at this code. And Sherlock, paid that on behalf of Optimism. And then there was also an audit contest where you could win up to $750,000 based on the bugs that were found. And so we got over 300 participants who all came in from places all over the world looking for bugs. And the combination of these 2 forces found 3 critical bugs in Optimism's 7th audit. So they had already done 6 more traditional audits where 2 people work in pairs to try to find bugs in the code. And these 3 critical bugs that could have caused, massive amounts of damage were not found until the 7th audit, until Sherlock looked at it. So again, just showing how crazy security is in this space and how difficult it is. And to break this down a little bit more, to give you some context, a lead senior Watson is just what we call reserved auditors. So there was one bug that was only found by the lead senior Watson team, Zach Obront and Trust. There was one bug that was only found by the community. And so that means some random person who just decided to show up and spend their time looking at these contracts found the bug. And there was one bug that both the lead senior Watsons, and the community found. And so the really interesting thing about this is if you only had the community, you would have missed a critical bug. If you only reserved the lead auditors, you would have missed a critical bug. And this is something that Sherlock has seen over and over again in our own audits. And it kind of is a good metaphor for the difficulty of smart contract security in crypto. After doing 100 audits, we've seen that if you don't have lead senior Watsons, if you don't reserve auditors, top auditors, hopefully, then you'll miss about a quarter of the bugs. You'll miss about a quarter of the critical bugs that will cause potentially all of the money in your smart contracts to be lost. And if you don't have a community-focused audit where anyone in the world can come in and participate and it's open source and they earn bounties, you'll miss about 1/3 of the critical vulnerabilities in your code base. So Anyways, that's just a little bit about why you should care about smart contract security. I think I'm running up on time here. And a little bit about what Sherlock does and is doing to try to make sure that smart contracts built by some of the top teams and the most talented people in the space are able to be secured as much as possible. But at the end of the day, you can never prove that it's 100% secure. So security is really difficult in crypto, and it's something that everybody should be thinking about if they're thinking about seriously putting smart contracts on mainnet, because it's so difficult and there's so many gotchas, and you can have the smartest people in the space try to look for bugs, and they'll still miss some bugs. As we can see here, if you don't have the lead senior Watsons, essentially, have missed 1/3 of the critical bugs in the audits that Sherlock has done, and those guys are the best in the space. They're the most talented Navy SEALs of smart contract security. So anyways, the takeaway is crypto is really cool because you don't have to give someone else admin access to your life savings, but it's really hard to make sure that the code is safe because you're only trusting the code. And if you are going to build something that you want other people to use and put their money into and hold value, you should care about security, because it is one of those problems that will never be 100% solved. So you're just trying to get to 99%, 99.5%, and have a great bug bounty program and do great audits and do all of these things. And that way you'll have the highest chance of making sure that your users don't get affected by hacks. And that's pretty much it.
Awesome. Thanks for that whole kind of preface of basically setting up the stage for the rest of the summit. It was really insightful, and really appreciate you kind of covering why this matters and really giving us an opportunity to go and dig into all these spaces and actually go deep into how to think about security for all different aspects of building in Web3. So I really appreciate it. We don't have enough time for questions, unfortunately, but as they come in, I'll send them to you directly, and I'll kind of fill in all the people in the audience with the answers. But I want to thank you again for doing this, and we'll see you all on Discord.
Awesome. Thanks so much, Kartik. Appreciate it, everyone.
All right. Time for our second talk for today. And for this one, I want to bring on Togrul from Scroll. I know they've been having a really busy week, so I really appreciate them taking the time to talk about how to think about securing and validating bridges, securing the validating bridges. We're going to cover a lot of what goes on into making that possible, and let's try to exit out of just looking at Solidity code for smart contracts and look into other considerations. So without further ado, let's welcome Togrul. Hi.
Hello.
Amazing. Well, thank you for joining us. I want to make sure you get the time and the full flexibility to get started. So we'll let you kick right into it.
Thanks for having me. So my name is Togrul. As Kartik mentioned, I do research at Scroll, but you can mostly find me complaining about things on Twitter. And today I'm going to give a short roundup about validating bridges and specifically how to secure them, because we've been talking and working a lot on the rollups for quite a long time, but there's all still quite insecure, and therefore there are a lot of trust assumptions that are not there by default that we currently have. So all of you probably heard about rollups, and you probably heard a lot of people say that they inherit some security guarantees from the underlying base layer, specifically validity, which in this in this context means enforcement of state transition correctness, though I need to add that requires the assumption that the underlying proof system functions correctly. So in case of rollups, optimistic rollups, fraud proofs, it's 1 out of n honesty assumption, and for zero knowledge rollups, that's typically the correctness of their underlying proof system. They also enforce ordering, which means that if a certain transaction sequence is finalized, unless a dishonest majority on the underlying layer reorders it, it guarantees that the sequence is always going to stay in the same order. It's going to remain immutable. Censorship resistance, which is difficult to define, but for this but just to simplify things, we can define it as a guarantee that a transaction, user-generated transaction, is going to be included in a block within a certain predefined period of time, assuming that the user pays enough in fees. And finally, data availability, which is just using the underlying layer's ability to distribute data to whomever needs to access it within a certain period of time. And that basically allows us to use the underlying layer to reconstruct the state for the rollup, and that's how we get all the trust minimized bridging that we have on a classic rollup. But in this case, in the case of this presentation, we only care about safety. So specifically, let's define safety for this use case as how can an adversary or a hacker steal your funds? And let's ignore fraud and validity proofs and that they enforce correctness. For this case, it doesn't really matter. So we have a problem. Smart contracts can have bugs, and validating bridges that rollups use are smart contracts, and they're complex smart contracts. So it's difficult to enforce the correctness. So, and the solution is upgradability. So let's say if we find a bug that is critical or quite a serious bug, we have to upgrade, and that we can't wait for, let's say, a month or 2 months before that upgrade is actually enacted. It has to be immediate. And specifically, we use multisigs for that in most of the current setups. And the problem with that is that they require an honesty assumption, which means that you degrade the assumptions of a validating bridge from the correctness of the proof system to an honesty assumption of the multisig. So let's say if there are 12 members of the multisig, you need to assume that 7 of them are honest, for example. And the solution is don't build smart contracts with bugs. No, I wish it was that easy. And actually, the solution requires it's multifaceted and it's quite complex. So problem one, and I'll divide the solution into subproblems, into 2 subproblems. Proofs are complex, and the solution is multiprovers. So what are multiprovers? Multiprovers were originally produced by Vitalik in 2022. It's during his talk at Rollup Day in Bogota that he first spoke about them publicly, and they were concretely expanded by a variation of a multiprover by a proposal by Justin Drake later in the year. Specifically this one, it's called 2FA ZK rollups using SGX. So essentially in this case, Justin proposes using SGX as a second prover and enforcing validity of the validating bridge, enforcing the validity only if both proofs agree. So you can think of multiprovers as a setup that requires 2 or more distinct proof systems to assert the equivalent output. So, and I'll give an example later. And if proof systems disagree, then the validating bridge halts. And then you can have various setups on how to recover from the halt. So you can use a multisig, which picks the correct one, or you can use governance to recover. But that's up to a specific protocol. That's an implementational detail. But what matters is that a single failure of a proof system doesn't cause your funds to be drained. And so for safety to fail, 2 proof systems have to have identical vulnerabilities, because if 2 have different bugs, it's unlikely that those 2 different bugs can cause the same state mutation that will allow the attacker to steal your funds, which means that the probability of this happening is quite low. I would even classify it as negligible. So an example of a multi-prover setup. So you can combine a Halo 2 prover with an SGX prover. So you have a proof system, a zero-knowledge proof system that is Halo 2, and you use Intel SGX as a second prover. And you might think that SGX, it doesn't have a great reputation, but luckily for us in this case, the security is additive because we don't rely the safety of the funds doesn't rely on SGX. It's purely additive here because if it fails, the worst that can happen, the bridge will stop. The prover can never steal funds from you if it fails. And if both function as intended, perfect, then the bridge function is as intended. no problems. We just continue as if there was only one prover. But then if one of the provers, so in this case, Halo2 or an SGX prover fails, the validating bridge halts. And as I described before, then basically we pass it on to governance or multisig to decide which of the proofs we pick as the correct one, and basically downgrade the security to a single prover, which is not ideal, but it's better than having a single prover that can just get exploited and drain, and the money from the bridge drained straight away. And we have another problem, which is smart contracts tend to be prone to bugs. And the solution is multifier, or verifiers in this case. And I was the one that actually proposed multi-verifiers. So the idea of multi-verifiers is to require 2 or more validating bridge implementations that assert equivalence of the state mutation. So what I mean by it is you essentially implement 2 different validating bridges just independently from one another, and they share the same storage. And essentially, before committing to the storage, we add a small, as minimal as possible, add-on contract that basically checks that the outputs of the 2 are the same. So in this case, if the validating bridges disagree, the validating bridge, the protocol just holds. So for example, you can combine a Solidity and a Viper validating bridge implementations. So you'll have 2 independent bridges, and a small contract that connects those 2 bridges. And if they disagree from one reason or another, the bridge holds, and then again we pass on the responsibility of picking the correct bridge to multisig or a governance, or again, it's an implementational detail. And again, it's not ideal because if there's a failure, you downgrade your security to a single bridge. But it's, again, as in the previous case, it's better than having just one validating bridge, because that means that if that single validating bridge is exploited, your money is gone. Whereas in here, the worst that happens, there's a liveness failure. So yeah, so as I said, if both validating bridge implementations function as intended, we just proceed as intended. So nothing happens. The user doesn't even notice that there are 2 different proofs, bridge implementations underneath. But if Solidity of the Viper validating bridge implementation fails, we hold. And of course, in both of those cases, there's a bit of a downside, especially if you combine the 2. And the downside is that the gas costs are relatively higher. So in this case, the gas costs would be roughly 50% higher. And plus, if you add a verifier, a prover on top, you'll add 10 or 20% more on top of that. So the user will end up paying more than in a setup where you only have one prover and one verifier. But the advantage here is that you essentially reduce the probabilities or minimize the probability of a proof system and a validating bridge failure, which will result in money being stolen. So the only thing that can happen in this case, again, is a liveness failure, which is not great, but it's a much better trade-off than having your funds drained. And now let's assume that we solve the problem of bugs on the prover and validating bridge level, but there can still be bugs on the specification level, so on the protocol levels, because if you specify the protocol in the way where it's vulnerable, even if you have no implementational bugs, there's still a vulnerability that can be exploited. And maybe formal verification can solve it. And basically, the assumption is this: the combination of multi-provers, multi-verifiers, and formal verification can potentially enable us to remove the need for instant upgrades. So in case of validating bridge, what would happen is you would have an upgrade, but it will be delayed. And that will, so let's assume that there's a multisig or there's governance that decides whether to initiate an upgrade or not. And this delay allows any users that disagree with that upgrade, for whether it's malicious or whether because they don't like the new features introduced, just to exit within that period of time. So Vitalik usually specifies the required delay as 30 days, but you can think of it as, roughly 30 days or more. So if that's the case, then you essentially have a system which guarantees temporary immutability, so the users don't have to worry about a dishonest security counsel or a team multisig upgrading the contract and stealing their funds, but also they don't have to worry about the bridge failing because there's an implementational bug or a specification bug on either the validating bridge level or the prover level. Thank you for listening to my talk. If you have any questions, feel free to ask.
Hey, sorry about that. I'm just having some maybe difficulties there. Appreciate the appreciate the talk. Thank you for kind of going through that whole overview and making it very concise and actually.
Thank you.
So hopefully we didn't take too much of your time making sure the mainnet is back, but I really appreciate this.
Yeah, thanks a lot for having me, and I will probably see you in either Istanbul or India.
Absolutely. Thanks, Togro.
Perfect. Have a good day. Bye-bye.
You too. Bye-bye. All right. Now that the EV issues are aside, I want to get ready for our next talk. So for this one, I want to bring on Sam to talk about DevSecOps and how you should think about blockchain security as a whole. So without further ado, let's welcome Sam from Guardrail.
Hey, Karthik. Is my audio okay?
Hey, Sam.
Awesome.
Everything was great.
Awesome. Thanks so much for having me. This is a really, really exciting lineup.
Excited to have you.
Awesome. Yeah, happy to jump right into this. Definitely really excited to see security as a huge focus for ETHGlobal. Been around at a few different hackathons, and it's always very, very exciting to see what the teams are building. So happy to talk about something that's very near and dear to my heart, security for the blockchain. And of course, today we're going to be hearing many different perspectives, thanks to both the early speakers before this. Really looking forward to the session after this too with the live audit. Today in this talk, I really wanted to go over what it means to secure the blockchain in a continuous basis. Of course, we've all heard about getting the audit. Of course, insurance is a huge part of that. But as developers, the question comes down to us. What can we do to kind of go ahead and protect our protocols, protect our contracts? And that's what I just wanted to go over at a highest level in this talk today. To give you a bit of background on myself, I'm the CEO and co-founder at Guardrail. It's a real-time security monitoring platform for the blockchain. And of course, when we're talking about security monitoring, that's a huge part of DevSecOps. So this is something that I spent a lot of time thinking about. And what I wanted to do today is share some of the learnings that we've seen working with teams across the space, just to bring to you guys what is the best that the best teams are doing. So given the audience today, it's going to be a mix of developers, security, maybe amateurs and security experts. I didn't want to go too deep into a specific area. So today we'll be going through a bunch of different realms of security. And then I'm happy to pick up this conversation offline and talk to any of you guys on any of the areas that are most relevant. With that being said, let's dive right in. This is a rough agenda. We'll just be going over what DevSecOps is, how it relates to crypto, and then a framework for how I like to think about DevSecOps in the space. And then we'll wrap up with some concluding thoughts. With that, let's dive right in. So first of all, some of you guys might be wondering, what is DevSecOps? It may be a confusing term. It may be something that you haven't heard of before. So to simplify it, really it's just DevOps and security put together. Pretty simple. Now, some of you guys might be thinking, okay, that's taking an easy way out. So what's the reason behind DevSecOps entirely? The reason that we're even talking about this at all is that over the last decade, the way we ship code and the way that applications are building are changing pretty rapidly. especially in blockchain, but even in the broader Web2 ecosystem. The cadence of deployments is growing very rapidly. This means that there isn't a feature freeze or security testing time. Once a quarter. Now code is being written every day. It's shipped every week, and that means that security is something that can't just be tacked on at the end, but needs to be integrated into the code development lifecycle. So that's where DevOps is talking about bringing in agile performances to code development, so that it's not something that takes a long time, but it's something that can be built in a more continuous deployment process. And then DevSecOps talks about how we can build guardrails around that to be able to not have it be kind of a gatekeeper that has to approve everything and add additional delay to what developers are trying to do. So really the challenge here is, how do we redesign the security function to fit into Agile? And of course, this is something that not just is relevant for blockchain, but it is relevant for the broader space too. If you're interested in learning more about this, actually just yesterday, Google announced a report. It's called the State of DevOps. It's released every year. It's really interesting to hear about how the broader tech ecosystem is dealing with DevOps. And today, of course, we'll be focusing on blockchain. But if this is something that you're going to be doing, deploying contracts, securing them continuously at launch, definitely encourage you to check that out so you can bring in the best practices. So with that, with a rough understanding of what DevSecOps is, let's talk about how it relates to blockchain. So first and foremost, when DevSecOps meets crypto, we have to recognize that rapid growth and experimentation is pretty core to everything happening in the blockchain space. The entire space is less than 10 years old in terms of the applications we're talking about today. And in that case, even the applications that are considered mature today, like L1s, they constantly have their own development plan, and a change on the L1 ripples up to L2s, ripples up to dApps, and ripples up to all the applications that we're building. So really, I think speed is at the crux of something that crypto is embracing, and that also means that security doesn't want to be the one thing that slows it down. I think that's what even the previous two speakers have been talking about. So while that's the premise of the blockchain space, when we actually look at how applications are being deployed today, generally it's still following what is the previous model, which is folks spend a long time building, and then it ends up into this code freeze of a month, 2 months, waiting for the right auditor or multiple audits. And then once the auditor signs off on it, it's like mainnet ASAP, launch it, and then start growing pretty aggressively. So there's this tension between wanting to go fast and not necessarily having the security systems and processes built to do it in a continuous manner. But then in the meantime, we're still doing kind of the initial version of this. So that's kind of one tension that we've been noticing across the teams that we've been working with. It's even harder because once a contract is posted, most times it's immutable on the blockchain. Of course, upgrades are a caveat to that, but upgrades themselves have their own challenges. But with smart contracts being infrastructure that's being pushed and being completely immutable, it can be very challenging to launch and come back and make changes to the system. To add to this, of course, it's a very challenging thing to do correctly. And if you look at some of the accidents that have happened in the DevSecOps world, it's not uncommon with even the biggest projects in the crypto space. There's 3 images right here. The first one is from Compound, having 162 million that was stuck because of a bug upgrade. Second one is from Wormhole, which had a contract on chain that wasn't initialized. All the attacker had to do was just initialize it, set themselves as an owner, and then go ahead and take over that contract. And then after that was also Aave, that was doing an upgrade and had over 100 million. So that's some of the biggest projects in the space. All 3 are 9-figure hacks. So this shows you that it's a very core part of what it means to build a successful protocol, but also when done wrong can lead to quite a few different accidents. The third one, which I want to touch on here as to why DevOps is relevant for crypto, is actually in the exploits world. So of course there's the speed angle and there's the accidents. But even for exploits, having good DevOps can really be a huge game changer. First of all, the attacks we're seeing today are existing in what we're calling attacker kill chains. So it's very rare that it's purely a single transaction. We usually see some level of reconnaissance, configuration, funding, the actual exploit, and then multiple different steps before and after the hack transaction. Of course, this may change as things move on. But today, this gives us the chance to be able to have the right systems in place to be able to stop this at any different point in the life cycle, to be able to stop the kill chain. So that's really exciting to think about how DevOps has that potential. Additionally, with one of the teams that we've been working with, we actually set up some monitoring for them to be able to identify, what was happening with the tokens in the broader blockchain, and we identified that there was some tokens being traded on FTX in an unexpected EOA that they were able to, using DevOps and monitoring, identify, pull those tokens out, and this was before kind of those tokens would have been frozen under the FTX kind of situation that ensued afterwards. So that was a huge win for them to be able to have the right monitoring in place. And then additionally, one of the teams that we work with also, they were able to set up a PagerDuty call so that when a major pool imbalance happened during Terra Luna, they got a call on a Saturday and were able to kind of emergency move some funds out. If they didn't get that call, they would have been 100% exposed, and with that call, they were only 20% exposed. So not an absolute get out of jail free card, but really the ability to limit the damage and be able to kind of help teams in critical situations. So that's setting up some context for why DevOps is important. And of course, as a blockchain industry, we don't want to give up the speed. We don't want to have accidents, and we definitely want to have better tools in the chance of exploits. So let's talk through how we can integrate DevSecOps into the workflows that we're all building today. And with DevSecOps, just want to call out that it's not necessarily like a simple tool or a plugin. It's not a linter or a code analysis plugin. It's more of a framework. And that's where it becomes really interesting to think about how it's applicable across every stage of the protocol. We've been seeing this in practice with quite a few different teams that we work with. And I broadly have been able to see it in 4 key areas. The design, code, transactions, and protocol is how I've been thinking about it. So right now, let's dig into each of these and really understand how DevSecOps is implemented in each of these different phases of the protocol. So when it comes to design, this is actually where a lot of us start when we come up with a project, either a hackathon or some of the biggest projects today started off with just an early design of what it could look like. Of course, that design involves mechanisms, tokenomics, and key application flows. But one of the core parts that touches DevSecOps is a threat model. So when it comes to threat model, this is essentially what we would call expecting out scenarios. A threat model talks about those scenarios being both like good and bad scenarios, and speccing out who the stakeholders and interactions are. Here's a quick kind of mental model I wrote out that you can use in to spec out who the users are going to be for your contract, whether it's which dApps would they integrate with, if it's hosted on Web2 infrastructure, what would that look like in terms of the different APIs and providers, which wallets you'd want to support and integrate with, blockchain smart contracts in terms of how many and what configuration you do there. And then, of course, what admin functionality there would be across the whole team. So those are just it's a very high-level version that I just put out here. It's maybe even a starting point for some of you all. But I just wanted to point out that as good as application design is, I think threat model is something that's the first step of DevSecOps for any contract. Next, definitely, early on, integrate logs, pre-design some testing scenarios, and come up with these invariants that you want to test. For DeFi teams, this may be, over collateralization. For NFT teams, it may be some level of liquidity or some invariants around their order book. But definitely think through logs, testing, and invariants for your application. And what some of the best teams have done here is actually limit the area of the code base that they expect to work perfectly. A good example here would be if you look at Uniswap's core and periphery contracts, and you're welcome to go check that out. What they've done is with core, it's very simple, almost like too simple, but that's kind of by design to make sure that there's very little scope for anything that could go wrong, very limited chances for exposure to happen there. And that way, periphery is where they can do all the interesting experimentation with user accesses, interfaces, and APIs, while core continues to be like the part that's battle tested and secure. So that's a really good approach that we've seen some of the best teams in the space too. Of course, even with this, it's really important to stay on top of the protocol changes that keep coming out. So definitely, review EIPs and standards as they're happening. I think when, the gas optimization EIP came out, 4337 came out, a lot of these EIPs have been really kind of conversation inducing in the whole space. And I think that's why it's really relevant to make sure that you're not ending up with that incompatible with the existing EIP protocol. And then the last thing I want to say here is it can be very frustrating if you're doing 9 out of 10 things right and one of them goes wrong. So really, it's important to be very consistent and continuous here. There's a couple of examples I can point out here, but the idea here is, if you get 3 or 4 audits and you have a really strong developer team, but the processes is not great. You have a locally deployed 3 of 3 multi-sig all in one place, or you have a developer pushing code directly from the laptop, and the laptop has malware. All the hard work you're doing on the smart contract side or even on the testing side can go to shame. So definitely be consistent across the entire stack, because that can actually be where vulnerabilities can creep up. So that's on the design. Talking through code, which is where I think a lot of us are going to spend our time. First and foremost, it's before you start building anything, really start with battle tested contracts where you can. This is where OZ's contracts like the ownable, initialization, utilities, these are amazing because they not only save you time, but they also save you vulnerabilities. These are battle tested and definitely where you want to begin if you're going to be building some of the more kind of templated versions of contracts. Definitely where I like to start if I'm going to be experimenting with any of the smart contract flows. When it comes to deploying a contract, fork testing used to be very hard. I remember trying to do this 3 years ago, but today it's much easier to do using things like Foundry or Hardhat. And the idea here is, any contract that you want to deploy, you can check contract state and account state before and after using a mainnet fork using Foundry or Hardhat. Not that high lift in terms of work, but extremely high impact to know that there's no unexpected changes happening in terms of integrations. Looking at time, and I think I might need to speed up a little bit here, but there's code security testing, which I think is really relevant and can save you a lot of pain. A couple of really awesome libraries put out by really smart auditors like Mithril, Slither, and Kidna, which I recommend you to check out. Dependency monitoring, which has come up in a lot of hacks recently. Not knowing that you forked a vulnerable version of a contract can be, quite an area of demise for some projects. So here, there's tools like CodeSlaw that have verified contracts, or Pinata that give you a bunch of different verified contracts too. And using those, you can make sure that any contracts that you're including are battle tested and don't have dependency risk. And of course, if you're using an audit, make sure that your deployed code doesn't stray too far from that audited code. If it is straying far, then just maintain that diff very carefully and go ahead and revise that very continuously. I'll speed through transactions. I think transactions is really interesting since it's both as a user of a protocol, but also as your protocol interacts with other protocols. There's going to be a ton of best practices that you should be considering when it comes to transactions. First one's being test nets. I think it's fantastic to see all the infra that the entire community is building around test nets. Ourselves, we've actually at Guardrail implemented a bunch of testnet support, and our teams that are launching really large mainnet projects will spend months on testnet, just creating bots and simulating test cases. So cannot say enough good things about using a testnet to verify that the protocol is working correctly. Investigation tooling, of course, you're welcome to use Etherscan, but you might want to think through some possible scenarios that come up and be familiar with tools like Breadcrumb, TokenFlow, and a bunch of other investigation tooling. I have my own stack, and I'm happy to share if you're going to go down deeper down that route. A specific monitoring for transactions. I think this makes a ton of sense when you might want to think about what are cases that you want to be alerted about. This could be bad sources of funds. It could be an unexpected contract that just got posted, funded by Tornado, that you want to know about. So there's a couple of these specific scenarios that maybe don't happen as often, but if they happen, you do want to know and be able to kind of get a chance to react. So this is where you can spend some time designing those and using a real-time monitoring platform. And then early on, set some limits and expectations for your own transactions. This is helpful too, since as you launch, you might want to create your own definitions of what a whale transfer is, what MEV looks like, or maybe even roughly some expectations of what hourly or daily contract interactions look like. And this can make it clear when maybe front running or exploits are about to happen. I'm just going to double check that my audio is still working all right.
Everything is good, and you have a couple more minutes if you want to go through
Awesome.
all of that.
Awesome. And then I think touching on protocols, which is I think where we spend most of our time. Definitely with design code and transactions, it's where it all starts. With protocols, that's where we're able to really work closely with our teams to build in DevSecOps and then obviously build in monitoring for them. Definitely feel like this is where stakes get higher. There's more operations, more chances for failures, and a lot more moving parts. So first and foremost is really to be able to track and defend your own protocol's perimeter and also the internal moving pieces. So this means really understanding what are the Web2 API keys and what privilege each of them has. On the Web3 side, which external dependencies are there, whether it's oracles or price feeds, or just making clear, how often you'll be doing upgrades and things like that. Of course, on the internal side, we've seen this also put us up a couple of teams in trouble, whether it's like tech permissions or malware. So these are all things that I think are really relevant for a protocol to keep an eye on when it comes to DevSecOps. Next, it would be actually standardizing key workflows around some of the more operational pieces that, as we saw earlier, could be places where things go wrong. Deployment, upgrades, and initialization are three ones that come to mind. Additionally, building in multi-sigs for admin or high privilege actions is a really good idea. And of course, these multi-sigs should be people that are able to piece out what is authorized versus unauthorized. But this could usually be like the tech lead and one or two other folks. But I think multi-sigs are a fantastic idea to re-implement at the protocol level. Of course, we're all hoping this doesn't happen, but in case something wrong does happen, definitely be prepared. Have an incident response plan with a clear point of contact, a clear list of who, based on criteria, who gets invoked and pulled into a war room. It's really helpful to have controls in place to begin with, so that in case you do need to take action on pools, you can go ahead and do that. And then, of course, some documentation and data to be able to jump through into any investigations. And of course, all of this might be a lot to do, and that's where I think these tools can be really helpful to monitor what's happening. The question I like to ask a lot of teams that are really on the way to growth is, if there is like 100 ETH transfer or a proof of concept that's hosted on chain, would you get to know that this hack just took place? Because I think it's really important that you're at least able to detect them. If not, go ahead and take some actions based off of that. Case in point, if you look at some of the largest hacks that have happened recently, most of them were detected by other folks, security researchers on Twitter, which is never a good look for a project. And then when it does happen, it's also it takes quite a long time to triage comms. So getting ahead of this is something that the whole industry is learning, but I think extremely vital to be able to do. Looking at the time here, I think I'm coming up. So really quickly, just some concluding thoughts here. I think as an industry, we're getting a lot more aware about security. I remember in 2017, it used to be the case that audits were optional and maybe insurance was part of the conversation. Today, it's mandatory that everybody's looking at best-in-class security tooling when they're launching. I think customers are demanding it and protocols are bringing it, and that's just awesome to see around the whole space. And including that too, I think the whole industry is getting a ton of practice with incident response, which is really getting the whole space a lot more mature, which is really exciting to see. I think I'm at time, so I hope you found this talk interesting. If it was, reach out to me on Telegram, and happy to continue this conversation. Thanks for attending.
Amazing. Thanks, Sam. Super insightful. And I think it's a great thing for us to actually introduce the best practices from just a non-normal engineering tech world. So it's not just about what we're seeing in Web3, but actually looking at all the decades of best practices at Forbes here. So appreciate you kind of going through this. If you have any other questions, we'll kind of relay them to you too from the chat. And of course, you kind of saw in the last slide, you can find Sam on those various platforms. And for those of you who join the live stream, you can actually just press the rewind button. You can actually go back and forth in time, so you don't have to wait for this whole thing to end to find it. But really appreciate you doing this, Sam.
Thanks, Karthik.
All right. Take care. All right. Our fourth talk of the day. But it's not really a talk. It's going to be more of a show. So I'm going to effectively get started here. I want to bring up Patrick Collins. You may know him as the person who taught you how to write smart contracts. But what we're going to do for the next hour is do a live audit and talk about everything that's broken about that smart contract in the code base and how you can actually look for a lot of these things yourselves and write more secure code. So I'm going to give Patrick as much time as possible here and stop talking. So Patrick, appreciate you being here. And I'll let you start the show.
Absolutely. Thank you so much for having me. Really excited to be here. Just a quick time check. How long do I have? Do I go to
You got an hour.
I got an hour. Okay. Lovely. All right, cool. I will respect that time box. Okay, cool. What's up? Welcome everybody. Thank you so much for that introduction. My name is Patrick Collins. I'll be giving a real quick presentation and then we're going to jump into the code. I want to have as much time as possible. Also, I will be looking at the chat from time to time. Excellent. Yes, let's get froggy. I see you in the chat. I will be looking at the chat from time to time to take questions. So let me switch over here to the presentation and let's jump into it. Actually, quick question for perfect. Okay, I was just about to ask to remove that. Okay, lovely. Live audit. We're going to be auditing a code base called Lottery Friends. We've heard a lot about security. We've heard a lot about all this stuff. Now let's get down to brass tacks. How do we actually do security? What does it take? What does it look like? What does it feel like? from, and what are all the tools at our disposal to make sure we are successful. For those of you who do not know, some of my information is here. Some of my socials are here. My name is Patrick Collins. I'm a smart contract engineer, security researcher, educator. There's my Twitter, my YouTube. I am the co-founder of Cyphern. We are a smart contract security platform, and we also run the CodeHawks competitive audits platform. And as I mentioned before, we have created some of the largest and most watched smart contract developer educational videos on the planet. The YouTube videos, we have number 1 and number 2 for the most watched Solidity courses ever created. So we've been doing this a very long time. Here is the agenda for what we're going to be talking about here. Number 1, welcome and resources. So I'm going to talk about some resources here. We're going to go over the audit process from a high level. Then we're going to jump into the audit. So I need to finish number 1 and number 2 in the next 5 minutes. So we have plenty of time to actually go over the audit. This is going to be the code base that we're going to be auditing or doing a security review of. Here's the code base. I'll have a QR code and I'll show this link again in a minute. It looks like I'm cutting off the bottom just a little bit. Let's fix that. Okay, lovely. Much better. I already have it queued up in my VS Code. Great. Okay. Anyways, so some resources. So number 1, for those of you who are looking to begin your security journeys, definitely be sure to sign up for CodeHawks. We are running an awesome program right now called First Flights, which are much easier fake code bases that we have created to give you a chance to find some bugs and get familiar, get used to auditing and doing security reviews, right? Give you some confidence, because a lot of these professional code bases can be very daunting. It can be very hard to chalk up a win. You can be working a really, really long time and get nothing. And these first flights are meant to be, hey, there's a lot of easy bugs to pick up in here to give you that confidence and show you, how to get better. So be sure to sign up for CodeHawks. And then finally, be sure to sign up, subscribe to my YouTube, go to web3education.dev as well, subscribe for alerts as well, because we are working on the ultimate Solidity security, smart contract, EVM, DeFi, assembly course ever created. And I have given out some alpha that it will be done in the next 30 days. If you see me on Twitter, tell me to get off Twitter and get back to making the course. Okay. Again, here is the code base that we're actually going to be working with. And before we actually get into doing this security review or this audit, and then also we want to talk about kind of what we're looking to do. There's a slight different mindset if we're doing this for a competitive platform like CodeHawks versus doing kind of a more traditional security review. In the competitive landscape, we want to optimize for time to find as many high impact bugs as possible. Normally in a private audit, we have a lot more time and we can actually focus more on, okay, what do we need to do to make this code base safer? And we give a lot better consultation advice. For the live audit here, we're going to assume that you're doing either or. We're going to focus more on this kind of being a traditional private audit where we are going to actually create a report at the end of this process with all the bugs that we have found. Next, so the audit process itself, it's really at a high level, these 3 steps: get context, use tools, do a manual review, and then write the report. That's really it at the end of the day. It's these 3 steps. The first step is actually the most important step. Most bugs are actually a result of some business logic being messed up, right? So it's a lot of times people think, oh, you need to be like this cryptography wizard person, but it's really just understanding the business requirements of the protocol is oftentimes more important than being a super, EVM savant, right? So getting context, what is the protocol supposed to do? And are there any scenarios where it won't do what it's supposed to do? So getting context is absolutely crucial for the first step of any code base, right? Read the documentation, right? Read the docs. Number 2, tools and manual review. We'll go over some tools and then write the report. And again, I have video on my YouTube, how to audit ENS, where actually legendary security researcher Tincho goes over his exact process for auditing a protocol. And it's actually really interesting is we recorded that video of him like, hey, like I'm going through ENS, like here's the approach that I'm taking. And 2 weeks later, he gets paid out $100,000 for a critical that he found, right? So literally we recorded that video. He's like, here, I'm working on ENS. Let me show you what I'm doing. And then he got paid out for some massive bug he found. Absolutely insane. One more thing. One more thing. There's like 3 more things. One more thing. You might have heard me say like audit and security review kind of flip-flopped a couple of times here. As security researchers, we want to take the more correct terminology here, and we want to say security review instead of audit. Security review is a much better representation of what we're actually doing, right? An audit isn't a very good term. I can explain that later if there's questions about it. But as security researchers, we want to see to the mindset of saying this is a security review. Most protocols won't know what the hell we're talking about, and they'll say, oh, like that's an audit, right? But it's important for us to say it's a security review and let the protocols call it an audit, whatever they want to do. Okay. The audit process more in depth. It's really kind of broken into 3 phases. This is a private audit and even competitive audits where you do an initial review. You give the report of, hey, here's all the stuff we found. The protocol fixes the issues. And then you do a mitigation review where you check to see, hey, if all the stuff that they fixed actually fixed the stuff or introduced more issues. And the more we do security reviews, the more we do audits, the more we look into security, the better we're going to get. Repetition here is the mother of skill. In the beginning, it's very difficult, and it gets easier. The more you do it, the better you get. Here are the tools we're going to be working with today. We're going to be working with Foundry. We're going to be doing a little bit of static analysis with Slither. I'll explain that as we actually use it. And then we will be working with Solidit as well, and I'll explain what that tool is when we get there. We won't be fuzzing for verification, symbolic execution, etc. If you're interested in those, I have a couple of videos of those on my YouTube channel. So now I will let people take some time, grab this link, and go to this code base, and we'll give people 5 minutes to do 2 things. Number 1, ask questions. And then number 2, see how many bugs they can spot. You have 5 minutes. This is obviously the most expedited security review you will ever do because I'm only giving you 5 minutes. But let's do it. Here's the code base. Again, you should be able to see the link, Patrick Alpha C, ETHGlobal Live Audit. You have 5 minutes. 5 minutes to find as many bugs as possible, and then we're going to start the show. And while we are doing this, let me answer any questions that have popped up in the chat here. I'm looking at the ETHGlobal.tv chat. Let me pull this up, actually. If you want to jump in the chat to ask questions, you can find that here. ETHGlobal.tv, that link right here. You can jump into the chat, ask questions. So 5 minutes. You all have 5 minutes. 4 minutes now. You have less time. No questions so far. Okay, nice. And while you're all looking, I'm going to take a swig of water. Can somebody paste this link into the chat? That's the first. Oh, thank you so much, nucleargeek.eth. Much appreciated. All right, I'm going to answer this. You can mute me if you want to spend some time looking for bugs, by the way. All right, first question. Are most of the bugs you find at assembly level or normal code level? Most of the time, normal code level, actually, not assembly level. Sometimes you find bugs at assembly level. Normally, if a protocol is using assembly, to me, that's usually, I usually kind of just almost like as a blanket statement, hey, like maybe try to avoid doing that. There's a reason we have compilers. But most bugs, the vast majority of bugs come directly from somebody doing some incorrect business logic as opposed to some weird assembly thing. What are the advantages of using Foundry over Hardhat? It's faster. Everything's written in Solidity. Those are the 2 advantages. I would say the advantages of Hardhat are just the opposite. Everything's written in JavaScript. So JavaScript is one of, if not the most popular language on the planet. Very approachable tool. Gives into the kind of the JavaScript everywhere mentality where, your backend's JavaScript, your frontend's JavaScript. So they both have their advantages. Big fan of Hardhat, big fan of Foundry. I like Foundry for a lot of my stuff. because it is faster, and it's kind of becoming the go-to tool for security researchers. Okay, 2 minutes left. 2 minutes left. 2 minutes left. Any other questions? If you find a bug, at the end of the 2 minutes, drop in the chat how many bugs you found. Don't actually say the bugs, just the number of bugs that you found. This code base has been kind of specifically tailored to have a lot of bugs in it. It's a little bit of a sneak peek of one of the modules in the upcoming security course. The code base in the security course is going to be a little bit different. I customized this specifically for this workshop. So this is a never before seen code base, and I will probably never use it again unless I want to repurpose it for some other content. Actually, I probably will do that. That's probably smart, right? One minute left. Any other questions before we dive in? I'm looking at the chat. Looking at the chat. All right. No other questions. If there's any other questions as we go along, feel free to drop in the chat. Like I said, we will be viewing that from time to time. All right. Cool. Well, welcome. So I have already cloned this. I should have got rid of that. That's fine though. I've already cloned this. It's already in my repo. It's already here. So we're going to be approaching this as if it is a real security review, as if we're actually doing a review live. So what did we say the first step was going to be? The first step for any code base is what? What did we say? Here's kind of the more advanced one. Here's the basic one. Get context, or scoping, and then reconnaissance, right? Really, we just want to understand what's this code base supposed to do. So before I even look into this code, and this actually has a pretty familiar, like I'm already very familiar with Foundry, so I know that all the main code is going to be in this SRC, all the tests are going to be in tests, script I can kind of ignore. I want to read the docs. So for this, all the docs are in this readme.md. All right, cool. I'm seeing some people post in the chat the number of bugs they found. Excellent. Excellent. Okay. So we want to read, what is this code base supposed to do, right? You can 100% look in the code base as you're kind of getting context here, but I like to just try to understand what this code base even does, right? And while I'm doing this, what a lot of people will do, what a lot of security researchers will do is they'll create a little folder or a little file or something called like notes.md or something, just some place to dump your thoughts, right? Some place to write down all your thoughts. And as you're going along, reading the docs, you can kind of put these thoughts down on paper. Some people print out the code base to write thoughts down. Some people write it down manually, whatever you want to do, okay? So let's read what this is supposed to do. And we're going to go kind of quick through this because we've got a lot to show. So this protocol is designed to be a fair lottery. Users can enter the raffle, and the owner of the contract takes a cut of the total pot as a fee. So right away, we understand a lot about what we should be looking for in this code base. The protocol is designed to be a fair lottery. Just by that, we say, okay, cool. I know how lotteries work. They often have a randomization, right? A random winner has to be picked to win some prize. Immediately, attack vectors start coming to head. Okay, is there a way to manipulate the randomness so that a not fair winner is picked? Is there a way to break some of the payouts? Is there a way to break the entrances? Users can enter the raffle, and the owner of the contract takes a cut of the pot as total fees. Maybe is there some place where the cut is incorrectly calculated? Is there a place where we can block the owner from taking their cut? All of these attack vectors can start to percolate just by reading these two lines. Getting context, incredibly important. Now we have some more docs here. Call the enter raffle function with the following parameters, an address array of participants, a list of addresses that enter. You can use this to enter yourself multiple times or yourself in a group of friends. Duplicate addresses are not allowed. So that's something we want to look for. Users are allowed to get a refund of their ticket and value if they call the refund function. So again, more attack vectors. Can I break the refund function? Every X seconds, the raffle will be able to draw a winner. Will be given ETH. So the docs are kind of messed up, and will be given ETH. The owner of the protocol will set a fee address, take a cut of the value, and the rest of the funds will be set to the winner. I actually meant to take this out. Before this, there will be no fee address, but that might be something right there. That's a vulnerability, or we just say, hey, you have this in the docs and it's not there, right? So now we know a lot more about what the code base is supposed to do. We've got some context. Now we can actually start, diving into the code base and really taking whatever steps we want to do, right? And like I said, as we were reading, maybe we took some notes like, look for X attack, it needs to be fair, whatever we want to do. Any notes in here? I probably wouldn't have put any notes yet, but oftentimes when I'm reading the docs, like a big DeFi protocol can be really complicated. So I will usually take a lot of notes when working with the DeFi protocol. And especially when you're doing a private audit or competitive audit, if you have questions during this context, this gain context piece of your security review, you want to ask a lot of questions. It's really important to have a highway of communication between yourself and the protocol so you can understand as much information as possible. So I probably would have asked a bunch of questions. Hey, what's up with this fee address? Or maybe not actually, because I think the docs are pretty clear, but that's because I wrote them. Haha. Cool. So we've gotten some context. We know what the code base is supposed to do. So maybe the next step that we do is we just try to run the test suite, right? So with Forge, we can build it with Forge build. Looks like I'm missing dependencies, so we're going to install some dependencies here. It looks like we need to install some dependencies. Let's go back to the README. Let's see if there's anything we missed. Okay, we need to run the make file. So if I run make, maybe that'll install the dependencies. If I go to the make file, not familiar with make file, don't worry too much about it. Basically, we just ran make, and it ran remove, install, build, and it looks like it has this install step, which installs these very specific Open Zeppelin contracts. Cool. So the make actually just did that for us. It installed all the dependencies. It ran remove, install, build, it removed dependencies before just to start clean, installed the dependencies, and then actually build it. Now we can run Forge build, which is like kind of the equivalent of like hardhat compile or Browning compile. And it looks like compilation went fine. Cool. So next, maybe I run the tests, right? And usually for Foundry, I do usually just check foundry.toml to make sure there's nothing in this config that's malicious. It looks pretty benign to me. So maybe then I'll run Forge test, just run the test suite, see what we're working with here. Okay, we've got some tests. Great. I don't see any fuzz tests or invariant tests or something. That might be something I take a look at. But for the most part, it seemed like a pretty standard repo with a not super advanced test suite. As a security researcher, if I'm doing competitive audit, that's actually music to my ears because I go, aha, these developers might not be as advanced when it comes to writing tests, and they might have missed something because of that. So as a private auditor, that makes me very nervous because then I go, oh my God, they don't have a mature code base. I'm probably going to tell them, hey, you need to do invariant tests. Like I definitely would tell them, hey, you need to do invariant tests, stateful fuzzing. If you have questions about what those are, we can talk about that in a little bit. Maybe I'll run Forge coverage, get a coverage report. Right there is something that's very telling. I see 0.7.6 of solidity. That should be a red flag. Why are they using this super weird version? And then we can see here, it looks like they have pretty weak test coverage as well. So around 76% of their lines are tested, 76% of statements, 70% of branches. That's pretty, 62% of functions. That's pretty low. So just by me running this test suite, I can pretty much guarantee I'm going to find some bugs. Why? Because to me, this says this is not a very mature code base because they haven't done a whole lot of testing here. So in a competitive audit, music to my ears. In a private audit, panic. Well, not panic, just like, oh, okay, now in a private audit, you're going to have to teach the client, hey, here's how you write better test suite, here's how you get your test coverage up, etc. So, and as you can see, we're still kind of getting context. What does the code base feel like? What does it look like? Security is kind of this journey, and we are on it. So now that we've done some of that, we can start to look through some of the actual code base, right? It looks like this is the main code base. It's lotteryfriends.sol. Because I'm very familiar with Foundry, I know I can look at their deploy script, which is in the script folder, and this will give me a good idea of how they plan on deploying it. Okay, it looks like they're going to be doing some stuff with Uniswap, some stuff with the WETH contract, some stuff with the USDC. And maybe one of the first things I do is I double check this, even though this might be out of scope. Sorry, I didn't talk about scope. Normally, whenever you do a review, there's a scope. I forgot to fill that in here. The exact contracts that you want to be auditing. For us, what's in scope is just lotteryfriends.sol, right? So in scope, lotteryfriends.sol. So the deploy script, if we find bugs in here, it doesn't matter, but this can still give us some good context on what to look for. So we see some compatibilities using an older version of Solidity, and we're going to be deploying this on the Ethereum chain. We've got some stuff about roles, which is great. But in any case, all just getting context, right? And this piece here, I probably am going to report this as an issue. Why are you using this old version of Solidity 0.76? Why aren't you using a new one, right? That's probably one of the first questions we're going to ask the protocol. Why are you using this old version of Solidity? But okay, cool. So now let's actually jump to the code base. And before, actually, I was thinking we would do manual review first. Actually, I am going to show you Slither first. So Slither is something called a static analysis tool. There's a static analysis tool. It's a tool that very kind of dumbly just checks the code base for bugs, but without actually running anything. It's called static analysis because it analyzes the code without running anything. The opposite of that would be dynamic analysis, where it's actually running some computation, right? So static analysis tool just looks at the raw Solidity and says, okay, is there anything I can kind of pattern match that's an issue? And most of the time, most code bases should run this before audit, but if they don't, you can run this. Now, I will say, if you're a competitive auditor and a code base runs and Slither finds a bunch of vulnerabilities, everyone's going to report that. Everyone's going to report the Slither vulnerabilities because everyone knows about Slither. It's a phenomenal tool. It should be one of the first tools that is actually run. So I kind of cheated a little bit. I put this little Slither config in here, which basically helps me run Slither. I've already installed it, so I'm going to run it. If you're not familiar with installing it, don't worry about it. If it's the first time that you've seen this tool run, see how freaking cool it is. So what this does, like I said, it'll basically read this entire code base. Oops. It'll read this entire code base, and it'll look for issues. It might take a hot minute to run, so we'll come back to it. I'm gonna hide the terminal for now while it runs, and we'll do some manual review. We will come back to Slither. But okay, we're finally in the code base. We're finally looking at code. And this is where we start taking notes. So right at the top of this code base, we see this little caret here. Pragma Solidity 0.7.6. My initial thought is this is a bug right here. And I'll put like a note in the code base. I'll say like at audit or at review or just whatever comment to say, hey, like this is an issue. I might say floating pragma isn't cool. I'm probably going to write something more verbose than that, but I might report this as like an informational finding. You really want to nail your solidity types as opposed to using like a floating pragma, just so that you're always using the exact compiler version that you want, right? Maybe maybe a test only works on a certain compiler version, so you really want to nail it to a specific version as opposed to using a floating one. So that's going to be my first finding. Just say, hey, nail this. Okay, cool. Next, looks like we have some imports. They're doing named imports. Love to see that. We have some package dependencies from OpenZeppelin. We're going to skip looking at OpenZeppelin. For us, we're going to say, using OpenZeppelin's a gimme. We have some interfaces that they're using as well. It looks like they're using this iUniswap v2 router. Maybe I cheated. I put the link in here. Maybe I compare their interface to the actual interface to make sure they're actually the same. They're actually correct. For now, I'm just going to ignore that and I'm going to assume it's correct, but I probably would double check to make sure it's good. And we're doing some other stuff from OpenZeppelin. Cool. One thing to note, we did install, where is it? Package.json. We did install a very specific version of OpenZeppelin contracts. That's great to see. In the make file, we got to see that. A very specific version of OpenZeppelin contracts. That's great to see, but it's also weird to see because OpenZeppelin v5 just came out. Why are you using this antiquated version of OpenZeppelin? What's going on here? Are you trying to rug pull somebody? What's going on? Anyways, finally into the contract. We have some comments. This will give us more context. I would read this. I would leave notes, but cool. Lottery Friends is ownable. Great. So we know that the owner of the contract who's going to be taking the fees is probably coming from this ownable stuff. We have all these state variables. We have this library that we're using. Cool. We have some more state variables. We have some events. Cool. Okay, cool. Here's the first actual function that we probably look at, right? The constructor. We probably might double check, make sure all these are right. I'm just going to assume they're right for now. I might start asking a question like, what is this swap path? Like, what the heck is this? I might put like a queue. What is a swap path? Why is this needed? Why are we doing some weird stuff with Uniswap? If we're unfamiliar with Uniswap, maybe we have to get some context on Uniswap. The rest of this stuff looks pretty straightforward. Obviously, I would probably take more time looking at this, but right now I'm kind of just skimming the code base, looking for any ideas. Okay, cool. We have this enter raffle function, and this is where we probably are going to start going line by line. And I actually usually like to look for I call it like one of the main functions. What is the protocol actually? What are users actually going to be doing? This enter raffle is going to be one of the functions users are actually going to be using. There's the refund function that they were talking about, where if a user enters the raffle and they want to refund before the raffle is up, they can refund. We have get, this is kind of just a view function, whatever. The select winner function, we're going to be looking all over this one. Withdraw fees, that's for the owner. Withdraw tokens, it looks like that's for the owner too. This is an internal function. And it looks like we have this weird Uniswap sell profits for USDC function. It looks like we're swapping the ETH we get paid for USDC to prevent currency risk. So for some reason, the protocol wants to swap the ETH for USDC, whatever they want to do. Cool, I guess. But so now we have some context of what the functions actually do. Actually, Foundry has a method that prints them out. We can actually start looking through some of these functions to make sure they actually do what they do, right? So now we actually get into the manual review. So this first function, enter raffle. These are what users are going to be doing. They give an address array of new players. Cool. It looks like they need to pay a require message.value equals some entrance fee times new players.length. Okay, cool. So for each player, they need to pay some message.value. Let's check entrance fee. Looks like it's an immutable variable. Great. It's set once in the constructor. Okay, that makes sense. All right, cool. And it looks like they loop through this array and they push each one of these players to the players array. Okay, cool. And then we have this weird check for duplicates where we again loop through and we check for duplicates. And right away, this is something weird to me. First off, when you see a loop, you really want to think gas. Loops are not great for gas. But why are we doing all this gas stuff here? And reading this, I see we actually loop through. So we have this players array, which is a state variable. We loop through this players array, and then we loop through it again to make sure that there's no duplicates here, right? And this already is an issue. This is actually a security vulnerability that we're looping through this players array twice. Now, why is this a vulnerability? Well, so, and then I might here just do like @audit. And then why is this sticking out to me? Well, the reason this is, ChatGPT is actually giving me some hints here. It is very expensive, but this is actually what's called a potential denial of service attack vector. Now, why is this a potential denial of a service attack vector? Well, as this array gets bigger and bigger, doing this check for duplicates is going to get more and more gas expensive. So if maybe when there's one person in here, maybe this function costs 10 gas because you only need to check for one person. But if there's 1,000 people in this, maybe this costs 5,000 gas. And it becomes incrementally more expensive for a new player to enter the raffle because of this super gas expensive check here. And now what I would do to so right away, because I've done this a long time, I know right away that this is an issue. But what I'll probably do to convince the protocol that this really is an issue is I'll try to write a proof of concept, an actual proof of code that this is an issue. And I have written a test for this already. And I'm just going to pop it on screen real quick. To double check this. Test, lottery friends test. So I'm just going to copy paste this in here. Call it, puppy raffle, whoops. Some hidden alpha, puppy raffle. Lottery friends. So what I can do now is I'm going to run this and cool, it looks like Slither actually finished. We'll come back to that in a second. What I'm going to do is forge test -mt. I'm going to run my proof of code. I wrote a test suite that proves that it actually is gas inefficient. And then I need to do -vvv to get my console logs to print out. So here are my logs. Gas cost of the first 100 players costs this much gas. Gas cost of the second 100 players costs this much gas. So I've actually written proof, and this is really good for competitive audits as well, to actually have a test that gives you something like this, that entering and sorry, I didn't show you the test. We're running a little short on time. That entering this raffle is actually going to get more and more expensive for new people. So what I might want to do if I'm a lottery attendee who wants to win is the instant the lottery opens, I bang up the queue with a ton of fake alternate addresses that are all mine so that it's incredibly expensive for a new person to come in and join the lottery. I basically say, hey, if you want to join this lottery, you're going to need to pay 100 times more gas than I did to enter this lottery, disincentivizing other people from entering the lottery, giving you a very unfair chance of winning the lottery, right? So we have found a vulnerability. We have proved it's a vulnerability, and we're going to write it up as a report. So oftentimes, auditors can write the report whenever they want. Let's assume we're going to be writing the reports as we do it. So we're going to say report.md. We're going to write our first report. very quickly because time is of the essence. Okay, cool. And so we're just going to kind of keep it some minimal markdown for now. First thing we need to do is we need to decide the severity of this issue. So, right, we know there's some denial of service attack here. We need to decide the impact and then the likelihood. So how impactful is this? I would say this is high. This is high. Maybe it's medium because it directly will affect other people entering this lottery, right? It makes it way crappier for somebody to enter the lottery, making this really not fair at all, right? It's going to cost the next person way more gas. The likelihood of this is high or medium, right? So this might be a high or a medium. It really depends. For this one, I'm going to say it's a medium because it will be incredibly gas costly for the attacker as well. So I'm going to mark this as medium. I think marking this as a high would be very reasonable as well. So I might say, all right, cool. This is our first M1. Let's call it a medium. And the way we want to, and the way we do reports here is we do it with this format. Write up format.md. I'm just going to copy paste here. So this is the format of a write-up. So you're going to do the severity, hyphen the number, description, impact, proof of concept, and then recommended mitigation. So the description of the attack, what is the impact, what is the proof that it's a real issue, and then what the protocol should do to fix it. And then for the title, we want to use the format root cause plus impact. That's how we want to title this. So if we copy this, bring it over to our report, paste it in like so. This is M1. What is the root cause of this is the duplicate check. We can say gas expensive duplicate check in, we go back up. What's the name of this function? In the enter raffle function. So maybe I'll say lottery friends, enter raffle. This is one popular way to reference a function. You say the contract name, 2 semicolons, and then the function name. Gas expensive duplicate check in lottery friends, enter raffle. Causes, remember, because we're doing root cause, impact, causes, denial of service, attack, making subsequent, I spelled that wrong, subsequent participants, causing subsequent participants to spend more gas to enter the raffle. Because we're a little bit low on time, I'm going to kind of speed through this. Got some of this already written up, so I'm going to cheat a little bit. Maybe like function loops to the players array, and this is actually lottery friends. Players array to check for duplicates. However, the longer the array is, the more checks the player will do, the more gas, blah, blah. Impact. This is where we would explain the impact. Makes it less fair. Blah, blah, blah. Proof of concept. This is where I would put my test suite. For proof of concept, you don't always have to write a test that actually proves it. Sometimes just explaining the exact steps is perfect enough. But here's what's really important. The onus is on you. And actually, let me focus on myself for a hot minute here. I know I'm running short on time. The onus is actually on you to prove to the protocol why this is an issue. Because here's what's going to happen for a private audit or a competitive audit. Number one, if you're doing a private audit, you report this thing to a protocol, you go, hey, this is an issue, but you do kind of a weak proof of concept. Here's exactly what's going to happen. They're going to say, I don't think so. And they're not going to fix it, and they're going to go get wrecked, and it's going to be your fault because it is your job to prove to them why they need to fix this. So the more proof you can put in this proof of concept, the better. In a competitive audit, what will happen is if you put up a lofty proof of concept, you don't write a proof of code, which like includes a test suite, the judge is going to look at your code base and go, I don't think so. Because it depends on the judge. If your judge isn't a very good judge, or they haven't been doing it very long, they're going to go, this is probably fine. This is probably not an issue. And you are not going to get that right up, and it is going to be your fault, not the judge's fault. So getting this right is incredibly important. When in doubt, if you're not sure you're getting across the importance of this, write a test suite, write a proof of code, prove that it is an issue. Drill this into you. It is your job to prove issues to judges or the protocol. You are an educator as a security researcher. Believe it or not, you are an educator. You need to educate why it is an issue. Great. Hopefully that is clear. Moving on. So this is where I would put, my code base. I would explain it some more, blah, blah, blah. Okay. And then finally, recommended mitigation. This is where you would explain what to do. I'm going to cheat a little bit here. I'm going to copy paste some stuff. Also have some diffs that I would give, like, hey, here's the exact code base I would change. But this is, at a high level, this is where you explain what to do. Excuse me. For this one, maybe we consider allowing duplicates. They can create new wallet addresses anyways. So like you preventing duplicates kind of doesn't do anything. Consider adding a mapping to check for duplicates, do something else. And then for the Puffy REPL, for the code base that this code base was designed off of, I even did some diffs. Get really good at doing diffs in Markdown. If we show what this looks like in Markdown, it actually shows, in green additions, in red subtractions, like that. And so like do this 3 backticks and then say diff, and then put pluses where you added stuff and minuses where you subtracted stuff. That's great. It makes it very obvious what your recommended change is. Great. I'm going to pause real quick for questions, and then I want to show at least one more vulnerability from Slither. I wanted to show 3. I was super optimistic. I wanted to show 3 manual review attacks and 3. We'll see how. I'm going to pause for questions real quick, and then try to rip through these last couple ones. On line 67, the duplicate check is not efficient. Nested loop has a complexity. Yes, exactly. It is a denial of service attack. Spot on. You found it. Well done. Excellent. Okay, cool. Looks like there's no other questions or I need to pause more often. If there's questions, we'll come back in a minute. Cool. Let me know in the chat if you're learning something or if I'm going too fast and this is not a very good use of time. Cool. Moving on. So we found an issue in here. Maybe there's more issues. I'm gonna get to the Slither in just a second. Maybe there's more issues, but we're gonna kind of speed up. Okay, cool. So then I would keep doing that exact process. Go line by line. I'm leaving. This is a loop for players. I'm leaving notes. I like to do this /E to explain something to myself. I'll do /Q to like ask myself a question, just some type of commenting syntax for you, right? And like I said, oftentimes I'll be going back and forth between the notes and the file to just dump as much of my thoughts as possible, right? So I would keep going. I would read through all this stuff. I'm going to do one more manual review find. We're going to do one Slither find, and then we're going to do the report. Add an hour, I approve it. Nuclear Geek, if only. We're going to do one more manual find. We're going to do one Slither find, and then we're actually going to do the report generation. And I have to do that in less than 10 minutes. Okay, cool. So we come to the bottom. Toggle word wrap. And we see this function here. Sell profits for USDC. This says it swaps the ETH for USDC to prevent currency risk on Uniswap v2. So, okay, cool. So we saw above players pay ETH it looks like we get some profits. And then this protocol is actually going to allow people to sell it. And then it looks like it's going to send that sold ETH for USDC. It's going to send it to the owner. Cool. This is where, if you're not familiar with Uniswap, you would need to get familiar with Uniswap. So this is where, again, context is important. If you know nothing about, sometimes you will have to go down rabbit holes. On that audit with Tincho, we would have to, we would say, hey, Tincho went down a huge rabbit hole on DNS. What is DNS? The domain name service. How does that actually work? And compared it to ENS. Okay. So sometimes you're going to have to go down rabbit holes to understand context. To really understand what this code base does, you got to know how Uniswap works. So even though Uniswap is out of scope for this audit review, to actually effectively audit this, you need to understand Uniswap. So we would read this and let's figure out if there's any issues here. As I go read this, if you see the issue, go ahead, drop it in chat. There's at least one glaring issue. So, okay, sell profits for USDC. Okay, the first thing I noticed, okay, why is this public? Maybe I'll put like, shouldn't this be external? If the contract doesn't call it elsewhere, this should be external instead. Maybe I'll put that as a question. Public, okay, why is this public? Should this be only owner? Maybe I'll ask this question. Should this be only owner? I'm just asking questions, right? Should this be only owner? Okay, I see amount, address this dot balance. Okay, that looks fine. Okay, here's the actual swap here. So it takes the interface, wraps it around the Uniswap router. We call this function swap ETH for tokens. We send some value, and then we have some parameters in here. Maybe I'm not familiar with these parameters. I'm going to control click or just go back to this interface. And we know, what are we looking for? Swap exact ETH for tokens. Okay, let's do a top of word wrap. What are the inputs? Amount, out minimum, path, to, and deadline. So just a real quick precursor on what these actually do. Amount, out minimum says the minimum amount that we want to get back. So when you're using Uniswap, it's an AMM, an automated market maker, and it uses pools to, without going too deep into how Uniswap works, it uses pools to figure out the price of something. But that price can kind of subtly change over time, and you want to give Uniswap, hey, like here's at least how much USDC I want back. The path, I'm not going to explain this for now. Address 2 is going to be the receiver of the USDC. And then deadline is what block we should consider this swap bad, right? Because let's say we send this transaction, we send it to our node takes a long time to actually send it, or maybe there's like a gas spike. The price might actually turn bad. So we want to say, hey, in a couple blocks, cancel the transaction, right? That's what this deadline is for. So knowing that, I could say, okay, so this zero is going to be the amount out min. Swap path, we're going to ignore. Okay, owner, this is the 2. So that's good. We're sending the USDC to the owner of this contract. And then we have block.timestamp, which is going to be the deadline. So right away, this should be kind of alarming to you. But maybe we think there's an issue here, but we're not exactly sure what it is. So one thing a lot of people do is kind of sanity check. Hey, this swap exact ETH for tokens, is there some other person who was reported an issue with this? Maybe let's go to, whoops. It's not important. Maybe there's some other person who reported this. We can come to the tool, Solidit, you do have to sign up, where we can search for somebody else who reported a finding using this function. So we'll put this in. It looks like somebody has reported this on another competitive audit platform, and we can actually read the details of this to see if this is similar to the issue that we're actually running into. For me, I know because I have read Solidit a whole bunch that this is actually a slippage issue. We can also look that up. We can do slippage. And actually, I'm sure if we read one of these, it would tell us what we want. Having the deadline be blocked.timestamp, this is saying that basically anytime you send this this function, this will always be valid because it's saying the deadline is the current block and it'll always check the current block and just always be valid. So we're saying there's basically no deadline to send this. And then number two, the amount out min is 0. Somebody could swap in, somebody could jump in, tank the price of ETH on Uniswap with a flash loan to basically make this swap worthless, give you 0 ETH, or excuse me, give you almost 0 USDC because your minimum is 0, and basically ruin all profits for the owner of this contract. So if you're unfamiliar with MEV, if you're like, what the hell is Patrick talking about? Sorry, we're kind of short on time. Sorry, I can't explain it. But this would be an issue. This would be a massive high, and we would report this. There's a slippage issue here. If you go to CodeHawks, if you're familiar, if you go to contests, this was a big issue in the Beetle contest, and this would show up on Solidit as well. And if you're interested in learning more about how slippage works, it's H4 sandwich attack to steal ERC20 tokens in the fees contract. It's basically this exact attack. If you want to learn more about what this attack looks like, I've also got some MEV videos on my YouTube as well. So I'll report that. I know I'm pretty much out of time. And also, yeah, somebody posted in the chat, can't block the timestamp be manipulated by miners. Kind of, it's a lot harder now that they're validators. But it doesn't really matter because you putting in block.timestamp here basically says that this transaction is valid forever, which is no good because a node could basically just hold on to this transaction until they want the swap to happen and wreck you for your funds, and they can make a whole bunch of funds. So I know I'm a little bit over time. He said I have an hour though, so I'm going to go for the next 3, 4, or 5 minutes. We're going to pull up Slither. We're going to see what Slither pointed out to us. This is kind of the output of what Slither looks like. It's categorized by red, yellow, and green. Green means it's low confident, maybe low impact that this is an issue. Yellow is kind of medium, and red is like this is probably an issue. And if we read these, there's actually a couple issues right out the gate. We have some arbitrary sending, and we have some weak randomness. Excuse me. We have some weak randomness, and then, arbitrary sends, some weak randomness. It looks like we have potential reentrancy and the refund function. We've got a whole bunch of issues that we would want to check out. And actually, for this code base, a lot of these issues are actually valid. So we would want to do write-ups for all of these. So that's what Slither looks like. Now, finally, let's actually do a report. So I'm going to kind of cheat a little bit. I'm going to cheat a lot. I'm actually going to give you a sneak peek into a bigger sneak peek into my upcoming course. So a derivative of this code base is actually this code base called Puppy Raffle. And this is my markdown report of that actual code base. So it's got 4 highs, 8 mediums, 8 informationals. At the moment, there probably will be more after I give it another whirl. But you can you want to put all your reports into a markdown file and then actually turn them into a PDF for clients because clients like PDFs. Report. Sorry, 1 second. GitHub Cyphren. We have a code base called, it's called like report something. audit report templating, where it gives you actually some templated markdown that you can use to help generate a PDF that looks really nice, right? And so this is kind of built off of that markdown here. So it has this like report example.md. It's a markdown file with a bunch of stuff in here just that you can kind of auto fill in for creating your own PDF report. Once you've filled all your stuff in, let's just assume we took our, we have our report. We took all of our findings in here. We copy pasted them into this template that we give us. Sorry, I know I'm speeding through this. What we can do then is we can run this report generation script here. Once we've installed Pandex and LaTeX, I'm going super fast. I'm so sorry. I was way too optimistic with how quickly I could do all that stuff. We can run this tool. I'm going to run it for you right here. It is Pandoc. Where did I copy paste this report as? 2023 lotteryfriends.md. Got to give it an output name from Markdown, a template, listing. Great. This will run it. This will take a minute, and it'll turn your Markdown into a PDF. And I forgot to add a logo in here. So let's paste my logo in here. Run it again. And then I'm done. All right, cool. And so now we have this output called report.pdf. For reveal this in Finder. We now get this very nice PDF view of our report. The logo that you added appears at the top. You can obviously change a lot of the stuff in that Markdown file, but it makes this like nice looking report that you can use for clients to be like, hey, here's my report. Here's how nice it is. Look at how nice it is, right? Cool. So I know I went super fast towards the end, but hope you all learned a ton. If we have time for questions, I'll take questions. If we don't, thank you so much for coming, and I hope you learned a lot. If not, you can find us on Twitter as Cypher and Audits. You can also find me on Twitter at Patrick Alpha C. You can go to, like I said, go to CodeHawks, cypher.com to learn more about some of these competitive audits, and stay tuned for the upcoming security course. So thank you all so much for coming, and hope you learned a lot.
Amazing. Thank you so much for doing that live, and not only just finding and giving us a good idea for all those bug reports, but actually making a PDF at the end that makes it easy for somebody to summarize what actually happened. This is a whole package, so really appreciate it.
Condensed. So
well, luckily YouTube lets us do 0.5x.
Yes.
So I'm sure people will be doing this at their own pace. But I really want to thank you for doing this, and hopefully we get to maybe make this a more regular thing where people can actually learn and walk through this for some of our bigger events.
Absolutely. Well, thank you so much for having me, and good luck, ETHGlobal hackers. ETHGlobal is a phenomenal hackathon to learn, build, grow. So looking forward to your presentations and your projects.
Thanks, Patrick. Take care.
Thank you.
All right, next up, I want to bring on Micah to talk about how do we actually think about taking risks and balancing between building cool stuff and making sure it's also safe. So given we're a little bit over time in terms of making sure things are on schedule, I'm going to stop talking and give Micah the stage. So welcome.
Awesome. Hey, Kartik. It's good to see you.
You too. I will let you take it from here.
Awesome. And maybe I can do some work to help catch up on time. But yeah, super cool. I think a lot of the speakers kind of in this series of content are going really deep in the technical side of things, which is really awesome. And I think it's super interesting for the hackers too, probably as part of this event. For this one in particular, I actually kind of wanted to zoom out and do more of like a bigger theoretical topic kind of talk to go over some of the bigger overarching problems that the industry is kind of working with, along with regulatory. I think the security, innovation, and regulatory is this like triangle that is balanced off each other. So there's a lot of interesting things that come into the mix. So hello, my name is Micah. I'm super excited to be here. And this topic is actually pretty timely because we're going through one of the biggest crypto cases in history right now, at least within the United States. We've got all the ETF stuff going on too. And then there's also global conflict happening that's been tied to some sort of crypto funding. It's a very exciting time to be alive. But I mean, this week, to make things even more dramatic, I started reading this book. I'm not sure if you can see this, Number Go Up by Zeke Fo. There's another book on FTX out there that has actually gotten a little bit more attention. I haven't read that one. But it's actually, this book has been pretty illuminating on the backstory of everything that's happened within the crypto industry and kind of the conniving side of crypto, which gives the crypto industry a kind of a bad name at this point right now with regulatory eyes. So it's really fascinating. Kind of wanted to dive into a lot of those things, but back to today's talk, I'm really pumped to dive deeper into some of the things that I had prepared for today. We're kind of living in this moment of inception right now, regulatory decision making, and we're probably going to be alive and long enough to see the repercussions of this new technology and how it ends up affecting kind of the world based on how the decisions are made. So for the time I have with you today, I'm going to dive into some ideas and perspectives around how we can strike the right balance between innovation and security in crypto that both benefits us as builders and operators in the ecosystem, but also providing value to the real world. So a little bit more on timeliness of this topic. If you're active in the ecosystem, which I assume you are, you've probably read a headline or two over the past couple months that have to do with crypto regulation. So each of these three screenshots on this slide in particular, it covers a different category of topic. But if you look at, like, for example, the upper left, Middle East regulatory clarity drives crypto industry growth. I'm calling from California, but we all recognize that crypto is a super global industry. ETH isn't from any state or jurisdiction. It's more of like an internet global thing. So that's one new paradigm that the world is going to start to have to get used to, but each region, again, is making their own crypto laws. So historically, a lot of these crypto companies that ended up being rugs or having shady practices decided to actually post up shop on countries that have more favorable laws, more flexibility, looser regulation, less checks and balances and rules, and so on and so forth. And that brought a lot of wealth actually to the country too, but it also left doors open for things which ultimately led to collapse of what we're seeing today. So luckily or unluckily, countries are getting a bit smarter about taking more care with their regulatory stances for the most part. So with the right regulation that balances things like openness to, and innovation for builders, technology like blockchain can bring a lot of opportunity to the countries. So you're seeing decisions being made favorably or more favorably in places like Hong Kong, Middle East, Japan, and so on. And then if you look in the upper right, this is very like current events kind of topic, and we'll get more into the numbers later, but there's been news lately about crypto being utilized by groups causing harm, right? And then we've heard Lazarus, and we'll get into the numbers of what's actually gone there too. So that's another thing to keep in mind as builders, is that there are real world connections to this technology that we prize and are super excited about that are causing real world harm. And there's a reason why regulators need to be involved. So that as an underlying tone, very briefly, I'll introduce myself. So my name is Micah Isagawa. I'm the CEO of a company called Legacy. We're working on safety around digital assets, and I'll explain a little bit later what that actually means. My background's in computer science and AI, and then prior to starting the company, I was at Microsoft doing cybersecurity with the government. And then I'm more on the innovation security side of things, of the whole regulatory triangle. And so I actually brought in a little bit of help from someone who is absolutely incredible. His name is Michael Mosier. He's an advisor to my company. I could list all of his accolades here, but it would actually just go off the screen. But he's just like the guy to go to if you want to know anything about crypto regulation, anything going on. And so a lot of the views from the regulatory perspective are actually from Michael. So very, very valid and very, very good points. So I'd like to attribute that to him as we go through this. So a little bit of a context on historical hacks. We've heard them all before, but at this point you've heard of the hacks. And again, the ones I listed on this chart, that doesn't even begin to cover the amount of hacks in the space. You can see starting on the left, 2011, Mt. Gox is probably the biggest name hack back then. And then over the years, 2018, 2021, 2022, the Ronin network hack, and so on. And we're still seeing many of them today. We're actually kind of seeing a little bit more, even with all the security tools we have in place. It's still happening, right? And these are just traditional hacks and draining. It's not taking into account things like stablecoins collapsing or individual phishing hacks on consumers and so on. So the numbers on the left-hand side, this is by millions. 2022 was a pretty bad year. Chainalysis says like 3.8 billion. I think it's actually more than that if you think about what hasn't been found, what hasn't been reported. So it was a pretty bad year. I would say we're doing quote unquote better, but if better is still $1 billion, we're not really doing very well. And so this is kind of the context of where we're sitting at within the hack space. And all this to say, like we as builders in the ecosystem, we may look at regulators as bad or restrictive, but at this point, there's kind of like so much money being stolen from consumers and institutions alike that they have to get involved. So I'll be repeating that point kind of over and over. The second point here, another reason why regulators have to get involved is that it's not just a financial crime. Like the money is being stolen and goes somewhere and then gets used somehow. So it's not good if that money is being used for nefarious activities or to cause harm to others. Lazarus, I'm sure all of you know what it is, but for those who don't, it's one of the bigger names of hacking groups in the space, allegedly tied to North Korea. But over the past couple years, they've been doing quite a bit of activity, and it's kind of ramped up in the recent months. So this number is from September. So I know we're in the middle of October now, but if you think back, in the past 104 days, they were responsible for stealing almost 240 million across different projects. And I'm sure there's more to come. And then again, Hamas has raised a ton of money through crypto. This isn't like a political statement. It's just a fact taken from the internet, but it's not a good thing if the crypto is going towards, or if the assets are going towards funding harm. So again, with regulation, I bet regulators would love to have to not worry about crypto, but this is just so obviously tied to it that they have to do something, and they're trying to figure that out right now. The last piece of context here, I think, is most important to us as builders. So Tornado Cash, you know the history. It launched in 2019. It's mixed a bunch of money. It's a tool for privacy and decentralization, which is something that philosophically I think we can all get behind. As human beings, we have our right to privacy. But around 30%, probably more, has been tied to illicit actors and illicit activity. So US Department of Treasury ended up blacklisting it in 2022. And then we also saw people like developers getting arrested for that. So this is kind of scary because as builders, it's difficult to know if something we build is going to be deemed wrong or illegal by jurisdictions down the road. And that's one big reason to push for regulatory clarity first, but also an opportunity for our ecosystem as builders to guide some of that decision-making by building responsibly from the get-go. So in the projects that you build, like now during this hackathon or later, that's something to actually keep in mind, because we don't want a situation like this where your tools supporting illicit activity, but you also don't want to restrict yourself in terms of innovation. So it's really this balance game that we're playing. So big point I want to dive into, number one, is that regulators have a lot of stuff to do, and we should let them do the other stuff. If you think about regulation, there is no crypto-only set of regulators. So they cover all of TradFi, and crypto is really only a really small piece of that financial stack. To give you a look visually, this is like kind of like you versus the guy she tells you not to worry about. We're a tiny, tiny piece of the overall global markets, 2.5%. So the crypto market is 2.5% of the global greater stock market. So looking at this, we're kind of like this fly in the wall that's causing a lot of problems. And in terms of value and volume, TradFi is actually a lot bigger. And so regulatory people have a lot more to worry about. Second point here, the best way to strike balance between innovation and safety in crypto is to manage risk ourselves as an industry. So the innovators, which is us and all the builders who are watching and building this weekend, we know the technology best. We know the innovation opportunity that is probably still unrealized, but we're also the ones that can envision that predictive future. And we don't want to stump our freedom to achieve that. That's completely understandable as builders. But the regulators would probably love to see that great innovation and so on, but they have to focus on managing the nefarious and bad activity that's going on. So yes, regulation is both to control and to protect. But at the end of the day, regulation is meant to help govern and keep people safe. So when we go into the role of regulation, I talked to a bunch of people that are more on the regulatory side of things, but there is very much common ground about the role of regulation, and the primary job is to spot and manage risk. And regulation is meant to balance cost and benefit, but regulators are naturally going to see risk way more than the opportunity in new technology. They're just wired that way because that's their job. Their primary job, again, is spotting and managing the risk, not building the new tech. That's our job. So we should let regulators be able to focus on the bigger issues, like what's going on in TradFi, by managing the risk ourselves. So if you think about it, like if we had been better as a community from the beginning of putting guardrails and risk mitigation in place, maybe some of these things would have happened, and regulators may have a different opinion of what the space looks like right now. Luckily, it's not too late, and we can start today. Last point I want to make here. So self-risk management by innovators is the key to finding the best balance of innovation and safety. So we have to build the safety, not just rely on regulators, because they're always going to be trailing the cutting edge. So I do want to talk about some companies that are actually working on it, companies that have been doing this without being told to do it so. And like Chainalysis is one of the biggest ones. Love them or hate them, they're creating products and services that are helping the ecosystem mitigate risk and analyze the on-chain data. So now organizations, government, institutions, and so on, they're coming to Chainalysis to help investigate things like cybercrime and other things that are going on. There's other companies like Chainalysis, TRM, Elliptic, and so on, just to name a few of them. And they're not just relying on regulators to help them govern and understand the industry. And on the other hand, other projects should actually be leveraging some of the tools and services that they're building to build security and safety and management from the ground up. It's not about restricting, it's more about keeping your company safe, as well as the people that are using the tools that you've created. I'll also briefly talk about us. So we are working directly on the risk mitigation problem too. The space from for a while now has kind of lacked some of the tools and services to help consumers and retail users keep their digital assets safe. So our approach is threefold. We do things in the assessment space like risk mitigation, real-time monitoring on the monitoring side, and then action-oriented items like emergency evacuation through our panic button and so on. But we build these tools and services with the consumer in mind, and then also have APIs on the back end to help projects protect their end users as well as their teams. So like in a nutshell, regulators hear more about the risk of censorship resistance and the benefit of the resilience of the tech. So they're going to hear the bad news way more than the good news, because the times people are going to be a victim, that's when they're going to go to the regulators to ask for help. They're not going to the regulators to shill how great crypto is or how much value they got from the ecosystem. They're going to go there when they get hacked for $1 million. And so they're just hearing all the bad news. And we have to keep that in mind, that it's kind of on us to change the narrative. So takeaway from this whole thing, the road has not been easy, and it's not going to be easy, but the less a government hears about needing to regulate us or get involved to help, the more we're going to be left alone. So I think it's on us to build for a safer Web3. And that's pretty much it. Thanks for the time. Please feel free to get in touch. If you or your team wants to leverage our risk mitigation tools, my DMs are open. We're building, you're all building. Hope everyone's having a good time.
Amazing. Well, thank you so much for going in through all of that. And it's a really good kind of refresher on just thinking about the problem by zooming out a little bit. So really appreciate that. And hopefully you also get to make it a lot easier for others to keep their assets secure with WebC. So thank you. And hope to see you soon. All right. Next up, I want to bring on a more technical talk around how do we incorporate formal verification. All of us been thinking about best security practice for Solidity code, but a lot of it so far has been around knowing what some of these patterns are or some of these exploits are. But there's a whole new field that lets us actually get better guarantees around all of this. And to talk through what formal verification is and how you can apply that to a lot of these DeFi protocols, I want to bring on Samir from Satora to talk about how you can get started with formal verification. So Samir, welcome.
Hi, thanks, Karthik. Hi, everyone. I'm Samir from Satora. And today I want to talk about formal verification and its application in DeFi, along with what we do at Satora to allow you to formally verify your smart contracts. So formal verification is an old computer science approach where you have a program and you have your specification, and you're basically checking your program against your specification, making sure that it is following the properties that you have laid out before. And these tools, they either give you like a bug, a counterexample showing you exactly how your protocol violates those properties, or it gives you basically an effective proof of how your protocol is like successful on all the properties that you have laid out before. So the first question that we can ask is like, why do we need formal verification in this domain of DeFi in particular? And here I've listed like a couple of bugs from 2022, 2023, Euler finance, year-end finance. And as you can see, all of these hacks have led to millions of dollars in losses. So one thing that is very interesting about this domain of DeFi is that the bugs have a very high impact. You can have millions of dollars in losses, and these funds are usually very hard to recover. So here, safety critical code becomes very important. Like even small bugs can lead to some huge vulnerabilities and can drain the protocols out of their funds. So code safety is very critical, and as you have seen, the billions of dollars are at stake. So you need something more than just testing, fuzzing, and auditing safety guarantees. And this is where formal verification can shine. It can give you these strong security guarantees that you need to make these billion-dollar protocols robust. Another interesting thing to note is that traditionally, formal verification has been very hard to scale because the code bases traditionally have been massive with a lot of files and data structures. But this is not the case with DeFi. Here, the smart contracts are very modular and they're isolated in the sense that they're captivated. They're just captivating one idea. So it's easier to deploy formal verification in the domain of DeFi, and it's easier to make use of it in this domain. But interesting thing to note is that even though the code is small and modular, bugs are still very hard to find in DeFi with just testing, fuzzing, and auditing approaches. And that is primarily because the bugs that actually lead to millions of dollars in hacks occur in rare scenarios. They are very strategic bugs. They only occur tricky edge cases. And this is another place where actually formal verification can shine the most as compared to testing, fuzzing, and auditing alone. Because formal verification allows you to explore this whole landscape of possibilities and helps you find the bugs in those rare scenarios that cannot be looked by with just the help of testing or fuzzing approaches. And as we all know, even though the code on the blockchain is immutable, the code is constantly updated because teams are adding bug fixes and new improvements. So it becomes imperative to make sure that all of these new changes are constantly getting secure with your properties. We need those strong security guarantees for every major update or every even minor update as well. In this example of Euler Finance, which is an interesting example where they had formally verified their original code base, securing it safely. However, it was a small change in a new PR that actually led to a bug, which led to $200 million in loss. And unfortunately, this new PR was not formally verified and kind of tells you about the importance of doing formal verification regularly and repeatedly in a regular development cycle. So hopefully now that I've convinced you why formal verification is essential in this domain of DeFi, let's talk about what other tools are available in the market that can help you get some more security guarantees. So first and foremost comes testing and fuzzing approaches, where you have random testing on many inputs. And some of the examples of these kind of tools are Echidna and Forge. So they're very easy to use. They find a lot of bugs, but the hard to find logical corner cases are not possible using testing and fuzzing approaches. Protocols that are dependent, that have many dependencies, or they call one another. Testing and fuzzing approaches are limited in their security guarantees when it comes to such protocols. Then you have the static analyses approaches, static analyses tools like Slither, Checkmarks, Veracode, where you analyze the source code to find for patterns that could be exploited for hacks. And what these static analysis tools do is they perform an over-approximation of the source code. They over-approximate the behavior of the underlying source code. So what can happen, however, is that they can lead to many false positives and negatives. So they can show you issues that are maybe not real bugs to begin with. So that is an issue with the static analysis tools by themselves. The third approach we have is that of like automatic formal verification, which we also employ at Satora, where you have your specification, your logical formal verification, and you reduce that into an equivalent mathematical formula, a logical constraint, and then you just pass it on to third-party constraint solvers like Z3, CVC5, and they give you either an effective proof showing you how exactly your protocol is verifying the specification, or they give you a bug showing you where exactly in the protocol a property is being violated. Of course, these automatic verification tools are computationally expensive and they take a long time. They sometimes do take a long time to run fully and find a bug. But as we'll see later, the computationally expensive part is not the hardest part about formal verification. And last but not the least, we have proof assistance, where you first write the specification and then you derive a correct code out of that specification. So the code will be correct by design. And tools like the K framework and COC help you design such secure smart contracts. However, the problem with such proof assistance is that they involve laborious efforts. They're very hard to use. They're not plug-and-play approaches, and they're just hard to scale in general. Looking at all these tools in a more pictorial representation, you can see that testing and fuzzing can find many, many bugs. They're very useful. And then you have the Satora Prover, the automatic formal verification tool, which can find even more bugs. And in fact, the Satora Prover can find all the bugs as per your specification. So formal verification is as good as your specification. If your program, if the properties that you have written, the specification you have written is like strong and covers all aspects of the protocol, then the prover will find those bugs related to those areas as well. And then you also have the static analysis tools, which find some bugs, misses some bugs, but then again reports some issues which are not real bugs to begin with. So we can also look at these tools in the scale of security versus automation. So security is like how strong of a security guarantee does the tool provide? How strongly can I say that my code is safe? Versus automation of how easy is it to use? How easy is it to scale? How can new developers just come and start using it altogether? So here we see that you have some tools like K and COC, which provide very high security guarantees, very strong robustness, but they're very hard to use and very hard to scale. Like new programmers have to spend a lot of months beforehand to actually learn the tool themselves to then make use of them in doing smart contract security. And then on the other hand, you have your fuzzing and static analysis tools like Slither and Echidna, which are very easy to use, plug and play approach, but they don't really provide a strong security guarantees. So this is where Satora tries to come in and comes at that like sweet spot of having, if not as expressible as COC, then equally as expressible in describing properties about a system. And of course, we try to be like as easy to use, but not easier to as your testing and fuzzing frameworks. So this is where we try to come in and make formal verification more approachable to new developers and veterans alike. So at Satora, we try to build tools that can help you verify your smart contract, formally verify your smart contracts. We have the Satora Prover that performs the automatic formal verification at the bytecode level. And then we also have tools like Gambit that can help you check the strength of your specification. A specification is just like a list of properties. And so you want to make sure that the list of properties itself is strong. And this tool can help by mutating the source code and then making sure that your specification is catching the bugs in the mutated source code. So this list of properties, the specification, is actually written in this language that we have developed internally called CVL, which is like a declarative language expressing what exactly a contract should do at any point in time. We'll see an example in the slides as well of our CVL. Yep. So here's a very simple example of a very simple contract where you have a very simple function f, and all we really care about this function is that it should never return a 0. So let's compare how we'll do a testing, fuzzing, and formal verification framework. So for testing, you will first instantiate your contract, your setting A to 3, and then you'll just check for random arbitrary values. F of 0 is not equal to 0, f of 1 not equal to 0, f of 17 not equal to 0. Great. So for fuzzing, you'll do something similar. You'll instantiate your contract again with the specific value of A, and then for all the random values of like 10,000, 100,000, you'll make sure that f does not return 0. Great. However, so there are two things to note in both of these testing and fuzzing frameworks. A, the value of A has been specified. Like nowhere do we say that, okay, A can be an arbitrary value. And B, like you're still checking for only a limited number of inputs, X ranging from 0, 1, 17, or like 10,000, 100,000 values. So this is where Certora and formal verification can shine, where you don't need to restrict your program in those manner. Like you see this rule that you write in a CVL, a declarative format. You say that, okay, let's consider X, which is an arbitrary uint 256 variable, and we want to make sure that fx is not equal to 0. We don't have any restrictions on X. We don't have any restrictions on A. What this tool does is like it explores all these possibilities magically and tries to come up with the specific values of X and A that can actually lead to a violation of the smart contract. So this is a very simple example, but this goes to show that the strength of formal verification for proving cool properties about your programs. And you can like extend this to your complex smart contracts such as ERC20s, ER721s, and other like pool contracts that allow you to write more complex properties about them. So here's like a brief overview of like the internal magic that is happening inside the tool. So you have your Solidity file getting compiled to the EVM bytecode using a Solidity compiler, and then it gets decompiled to an intermediate representation called TAC. And parallelly, you have a formal verification spec, which is written in CVL, as we have seen, and that too gets compiled to this intermediate representation TAC. So both of these things are combined together into a huge blob of TAC, which goes through a bunch of like simplifications, optimizations, and other things, and then get passed on to a very long mathematical formula, a constraint equation that gets passed on to like a third-party SMT solvers like Z3 and CVC5 that either give you a bug showing you how your protocol is violating the specification, or it says that there is no bug. So you're basically getting a proof that, hey, your protocol is is completely valid as per the specification. Of course, there is an issue where the tool times out, and this is because SMT solving is like a computationally hard problem, and there can be cases where the tool times out and does not report either of the two cases. And this is what we do at Certora. We try to minimize timeouts. We try to make sure that the tool can generate an outcome in most possible cases. So a question that we often get asked is that where does formal verification fit in the development cycle of a developer? And the answer to this is that we try to push a verification-driven development approach for formal verification. We want you to think of formal verification in the same way as you think of testing and fuzzing. For testing, you write your function, you write some unit test for that particular function before moving on to a new function. In a similar manner, you write your function inside your protocol. In fact, even before writing a function, you think about the property for that function. You write the invariant for that function, and then you come up with that function, and then you make sure, using the prover, that the function actually adheres to the invariants that you have specified in the specification. If not, you can go back, maybe change the function, or maybe change the design of the property itself, make it stronger. But if it is verified, great, you can do your development forward. So formal verification is not something that should like only be left till the end of a development cycle. It should be deployed continuously throughout the development process so as to make sure that you're developing a sound and robust system to begin with. Another question that gets asked often is that, does formal verification replace auditing, like manual auditing? And the answer to that is, of course, no. It's formal verification, auditing, testing, fuzzing, all go hand in hand to improve the overall security of your contracts. Nothing is like a silver bullet that can help you secure your contracts from all these hacks. So you design your DApp and then you write your code for it. But parallelly, you also write a verification, like in your CVL, like you formalize that verification and requirements using like a formal language. And then you test your code against that specification, making sure that your code follows those properties. But more importantly, you also check the specification itself, making sure that it is actually the properties that you want. Or you can make use of tools like Gambit at Satora, where you check the specification by mutating the source code and introducing bugs in the source code itself. Then you get a bunch of verification reports. And at the end of the day, of course, a human has to look at those reports to make sure that the code is following the properties. The properties are what you expect it to be. And the whole system is working as expected before you can deploy and publish the protocol. Now, many people think that formal verification can only prove an absence of bugs. However, I think the biggest value of formal verification is in finding those tricky edge case bugs that are very hard to find using testing, fuzzing, and auditing frameworks. Even in the case of like hardware analyses, the biggest value of formal verification has been finding some rare to find edge case bugs. And as I mentioned before, the hardest problem for formal verification is not the computationally extensive part. Yes, it's just true that it exists. But in practice, we see that a harder problem is for people to write good specifications about their system. The system design is a harder problem because it requires like a bunch of analysis, a deep understanding of the system. And we have seen many times where the specification falls short of covering every aspect of the system. And as I've alluded to before, formal verification is not a silver bullet. It's not going to replace auditing, testing, and fuzzing. But you have to think of formal verification as an additional aspect that you can utilize to enhance the overall safety profile of your code base. It increases, like, everything combined together should make your system more robust against hacks. And as we saw in the last slide, formal verification is not something that should only be thought of as like a last step, one last time deal once you have done the development. It should be thought of at the beginning. In fact, even before you start writing code, so that it can help you design better properties about the system, and at the same time, like, write better implementation for adhering to those properties. So all in all, formal verification can be a very useful tool that you can employ in your arsenal to secure your smart contracts against bugs and hacks. And yeah, thank you everyone for giving me the time.
Thank you so much, Samir, for that great overview of how to think about formal verifying your code and some of the best practices and tools that you can use. So it's really appreciated.
Thank you.
All right. With that, we are ready for our last talk for today's summit. And for this, I want to bring on Peter and Lev to talk about how do we secure zero-knowledge implementations. Everybody's been looking at Solidity code for the last few years, but a whole new revolution is about to come, and it changes a lot of things on how we understand how to write code with more math involved. But it's not bad news. There's a lot of good ways you can make this easy for yourself, and I'll have both Peter and Lev talk about how to get started. So without further ado, let's welcome them here.
Yeah, hello everyone. So let's get started. let's good morning, afternoon, evening, everyone, for all the hackers. I'm Peter, and I co-founded Auxorio. We're working with ZK audits with my partner Lev Menshikov. He's also today will help you guys to build the secure ZK circuits. If you would like to participate, there is a great sponsors like Scroll and Polygon and Aztec. All of them are working on ZK, and this is where you field and so many typical mistakes people always repeating with their code. We are here to help you to understand how we can mitigate these things and what is what the basic things and how we can protect your code from attacks. So we will start, we will introduce you 7 most common things, like basic attack vectors and how to protect them, and also bring you some real world examples of the errors and attacks that was happened in ZK field. Okay, I would like to start, and I think I will give a talk to Lev. We will start from our first most basic thing, most basic attack that you can see that every beginners happens, because ZK circuits, they are very different from original, from Solidity or other things. Lev, are you here?
Yeah, hello, can you hear me?
Yeah, all good. Let's go.
Yeah, and nice to see everyone, guys. Hello. So the first type of vulnerability is under-constrained and non-deterministic circuits. We have merged them into one type just because those two types and non-deterministic circuits in vast majority of cases is simply under-constrained circuits that additionally involve the break of determinism principle. So we have decided to merge them. So I just cannot operate. Oh yeah, I can move it. So to understand that vulnerability, well, first of all, let's define what are constraints in ZK circuits. Circuits are generally just a bunch of mathematical checks that are packed into mathematical equations that are stored in a one CS file. So, and if prover passes all of them, for programming just means that he knows the secret witness, and then he can produce a correct, a valid proof for that witness. If there are not enough constraints, it just means that there are multiple ways to generate proof. It means that we can produce several nullifiers, and then the logic and the actions of our prover, of our malicious prover, will be unaccepted to us, and it means that just our circuit is vulnerable. So, and also we have to possess that if our circuit is under-constrained, it just means that we cannot provide our users with the guarantee that our proof is legitimate and our soundness principle is broken. Let's move deeper. To understand that, let's see the following code example. As you see, it's just the template that takes 3 signals. The first 2 are just factor inputs, factor 1 and factor 2. And our program just checks that the product of those 2 signals is equal to our public signal val. And guys, this question is to you. How do you think? How many problems here? And you have the ability to watch it by yourself and write it into the chat while I'm going to explain that. So there are 3 core problems here. First is that our template doesn't check that the factors are not equal to 1. The second problem is that it doesn't check that the value of multipliers is positive. And the third one is that the product of factors is less than the order of the finite field, which is the typical example of wraparound effect. So we will talk about that in the near future. So you can see it here. So if our field order is 100 and our val is 10, we can just, if we are malicious proof, we can just provide 10 and 11. We will get 110, which is more than the field order, and then we will have the ability to create a malicious proof that will be valid. So, and also we have some part of the example of under constraint circuit. So if our public parameter p is 9, so there are 4 cases in which we can create a valid proof. So -3, 3, 1, and -1. All those inputs will be correct for our under constraint circuit, but of course determinism says that we can create only one valid proof for one secret witness. So our proven system just have some bugs, as you see. Yeah, we have already watched this. The second one is arithmetic overflows and underflows. It's quite basic. So it's just about when incompatible inputs are used together, and we will see that. First of all, we have to possess that this vulnerability occurs due to the mathematics behind prime finite fields. As you may know, it is all about linear algebra and modular arithmetics. So, and to first of all, let's understand what are prime finite fields. It's just algebraic fields that allows us to perform addition and multiplication modulo p on the set of elements that are constrained by from 0 to p minus 1. So, and overflow occur when the result exceeds upper bound, and underflow performs when the result is outside of the lower bound. So, the classic example of that vulnerability is semaphore double spending vulnerability, which was conducted by Roman Semyonov.
Yeah, let me describe that. So we have actually only half of the time, and this is the last session. Let's speed up a little bit, and we will. The previous, was like the very basic that you have to know, and this is a real example of like our friend that found that there are so many libraries that work with ZK are vulnerable for double spend. And that happens because in Solidity you use field like in power of 256, and most of ZK circuits work on the BN254. And when you just port numbers to the circuits, you just get classical overflow issue. And this bug affected by like more than 10 working projects at that time. So it happens in 2019. Yeah, and we want to describe this example very briefly. So how it works, pretty straightforward. You just get very big number and get overflow, and when you check the balance, you can easily find the 2 witnesses that will give you the correct example, so you can use it for double spend. So the next one is, I don't think we will go into the deep details here, so I think we can skip like to the basic thing. You can check the Kobe fix it quite quickly in ZK drops, and Circum was affected. Everything was fixed, and luckily nobody was affected by this issue. But this is classical overflow that really principal things that you have to worry there. Okay, the next one is mismatch in bit length. So also, like, you always work with a bit and bit masks in circuits, and it's very easy to just just found that you can skip some check inside, and if you will give signal with the more bits that is assumed to be calculated inside, that then you can get the mistake that give you wrong output. Maybe Lev, you can give some more examples here.
Yeah, on the slide you just can see the classic attack scenario when we have an input 0 that is that has a length of 3 in binary, and 9 which is 4 bit length in binary. So, and we have a mismatch here. So in the result of processing, we just can see that 1 is more than 9, which is of course is back. So that's the classic example of that attack. Yeah, and the mitigation strategy is just to use num2 bits included components. You just wrap them and constrain your inputs using that, and then you give those inputs into our less than vulnerable program, and all works fine, because we then just ensure that our input is less than the second input. So all works okay in that symbol.
Okay, the next one is not quite, but it's not obvious one. It happens with unused public inputs. If you use signals and public signals that you will not use, it could be optimized by and at the beginning it looks like it's not a problem, but for example, if you use and your proof should be unique, it can cause some wrong assumptions because malicious person can give you different kind of signals. For in this example, like signal 3 can be any kind of signal, and if he provide input 1 and input 2, which is correct, he can use any public input 3. For example, in semaphore, for example, the next slide is attack scenario. In semaphore, when you use ZK for sending anonymous messages, malicious person can generate as many proofs as he want with different kind of messages.
Yeah, with the same basic inputs. So that's the problem. And the core mitigation strategy is just to use those variables in some logic, in some mock logic that are not in demand, but we declare our using variables, and the all is fine. Optimizer doesn't ignore that, so all works okay.
Okay, we have the last 2 minutes, and let's go like very briefly. The frozen heart is a general name for a set of the errors that accompany the trail of bits. You can check the ZK docs links, and there are so many problems happened with them. For example, with the broken of soundness, and it's also related with trusted setup leak. I think we will talk together because of very common thing, and that happens in 2019 with Zcash initial ceremony because of incorrect operations with toxic waste and different kind of parameters. There was interconnected with each other. So but it should be independent. But lately, the researchers from Zcash found that you can recover the toxic waste, and you can generate the proofs, and you can emit as much money as you want. Luckily, they fix it in next update, and nobody affected. So we will skip the trusted setup mechanism. So because of lack of time, I will tell you
Quite
about
basic
the
knowledge, You
yeah,
can just
and about but just check that you use standard libraries and use some basic things. Don't try to write your own cryptography. This is the most important thing. And the last one is just very minor thing. Looks like sometimes coders misplace constraints in variables. So sometimes you think that you put more constraints and check some variables, but actually you didn't it. You can find it in many circuits, these kind of problems, and it causes the potential malfunction of your programs. So here is example. The very basic example. You can check how it works. Lev, do you want to add something there, or you?
No, it's quite basic, I guess. We can skip that.
Okay, so this is the end. It's time to hack. In conclusion, I just want to say, like, programming of zk snarks is not the typical programming. Check how finite private field works. Check more how you have to build these constraints, because there are so many things that works completely different in circuits rather than in normal Solidity programming on other languages. We will here to help you. We show you the 7 common bugs and pitfalls. Of course, there are much more, but this is the basic things, like same as in Solidity, like double spans. Everyone have to know about this. You have to know about these basic things. And we're here to help. If you want to build circuits, feel free to contact us. Happy hacking, guys. And I hope you will be fine and safe. If you need any advice, feel free to ask me or my team, Axoreva. We are very welcome to help with the consulting, audits, and just to help new hackers to dive into this field. Yeah, so feel free to check our blog. We have a lot of research papers there, and happy hacking. Thanks.
Peter, thank you so much. It's always great to see previous attendees who know exactly what the developers need to kind of come in and give them the right guidance. And this was super cool. I think this just opens up a whole new path for us, spending more time telling people about how to think about verifying and writing safe circuits. I think it's a topic that hasn't been covered enough yet, but I'm glad that we're starting it through YouTube. This was amazing.
Great. Thank you. Yeah.
Awesome. Well, I want to thank both of you again. And that officially concludes the summit on security. So I want to quickly just give a massive thank you to all of our speakers. We had 8 people come in and do 7 talks on all the cool things that you can look forward to in writing safe code, and some of the best principles around deploying things that other people are using that does not have any downside. So thanks again, everybody. And last but not least, just a reminder to all the hackers that project submissions are due this Sunday. So make sure that you are doing all the things that you need to do in the next 48 hours, because that's when you have to submit your projects, exactly 48 hours from now. So thanks again for tuning in, and we'll see you all next week with our finale, another summit, and all the things that have come out of our biggest ever hackathon. Take care, everybody. Goodbye.